like majorly your questions will be from week 4, 5 and 6. That means up to logarithm.
Achha,
Okay,
questions
got
can
it.
also come from week 4 also.
Yeah.
Achha,
So you have 4 weeks to cover. So I mean, basically up to week 6, it can be asked anything. So that's
Yeah, I saw
Okay.
that there is a SSC question on the logarithm.
yeah. Okay.
Yeah.
Yeah. So you will have this coming up. So you know why we give emphasis to this SSC is because you will have similar concepts coming up in machine learning later on in your courses. So we just give bit
Okay.
emphasis to this because this is one of the model where you do some kind of fitting here, right? And not exactly see. And what we do here is we'll be given set of data and then we ask you to find out what's the value of n, right? But as you advance in mathematics, like as you know, as you go through maths to content as well as some stats to content, then you'll be able, then you will have certain algorithm wherein you can actually find out the slopes, so let's not get into that part right now, it's deeper. So okay, we can start our session. And I say like, yeah.
So just want to ask one thing. What will be the syllabus for the first semester? Like, is there anywhere is available? Because
Syllabus for first semester, is it?
yes, for the entire semester.
You mean end term exam, isn't it?
In the
Yes.
orientation itself, the professors displayed all of the course content.
I think it is there in the student
semesters.
handbook.
Yeah, and
Ah.
even it is there in student handbook, so you can refer that.
Okay. Thank you.
Yeah, welcome. So all right, so we can start with today's session. So what we'll do, so you might have some disturbance from my end because right now I'm working from home, so some disturbance will be there, so please pardon me for that. So now let's just discuss what we know about exponential function. Okay, so just quick recap. So we know that a function f of x is given a to the power of x is an exponential function, right? And what are the conditions? What should be a? I want you to
0 and 1.
0.
Between 0 and
1 or greater than 0.
so it should
Sorry,
be
greater
between,
than 1.
Greater than 1.
okay, so we can just simply say a is greater than 1. Can't I write half to the power of x?
And that is between
Yeah, you
0
can.
and 1, right?
I can,
Yeah,
right?
which is between 0 and yeah, you can write.
So it should be greater than 0.
Yes.
All of you?
Yes, sir.
Yes, sir. Greater than 0, but not 1.
But not 1, is it? Yes.
Yes,
And
sir.
it cannot be, a cannot be 1, right? Okay.
Yes, sir.
And what about x? X can take any values,
Yes, sir.
right?
Yes.
Yes.
Domain is R.
Domain is R, right? So we know this much. So, and we also gone through the inverse functions, right? So we know what are inverse function, isn't it? So basically inverse of exponential function is logarithmic function. Okay, I hope you know this. And how do you know, how do you get the inverse function of any function? So you see graphically when you look at, so, okay, let's not get into graph right now, but let's understand this, what it is first of all, right? So you know that inverse of an exponential function is logarithmic function. So, and how do we know this? So now if I bring this here, this is my exponential functions. And when I take inverse of this, so I can simply say that, let me consider this f of x as equals to y and then take this as a to the power of x. And if I'm finding the inverse of something, then I can, I can take this as log y, which I can write it as x log a. So I'm considering whenever I write log, you consider that this is to the base 10. Okay, you can take any base, but here we'll be taking as 10. Okay, and now since we have to express this in terms of x, so we can write this, wait, let me take this as to the base a only, so that will not have a change of base thing coming up here. So then we will have log y is equals to x. So now what do you see? So this basically, like when you have changed this, so we can say that f inverse of x is basically log x. Okay. So now what you see, our function f of x was a to the power of x, and the inverse of this will give me f inverse of log x, right? So you, of course, you have the standard way of doing this, finding inverse, but I have just did it in a trivial way. But this is, I just wanted to convey this, that inverse of exponential function is logarithmic functions. So now we also know that we know what is even function, we know what is odd function, right? So even function is symmetric about y-axis, correct? So we know that even function is symmetric about y-axis, right? What about odd functions?
Symmetric about origin.
Symmetric about origin.
Origin.
Symmetric about origin.
What about inverse function?
Mirror
Symmetric
image in
about
y
y
is equal
equals
to
to
x
x.
sign.
Y is equal
Okay,
to
so
X.
inverse function is basically mirror of y is equals to x. So now let's understand this. How is this happening? Because I just told that inverse of exponential function is logarithmic functions, right? So now if I have to see this, how does exponential functions graph look like? So if I have to take a to the power of x where a is greater than 1, then you see this graph is something going to be like this, right? So this is my a to the power of x, right? What about and this is going to be 1, right? Because it at x equals to 0 you will have this being 1, right?
Yes,
Now
yes.
what about log x graph? It's something like this. So it goes something like this. Okay, so this is our log x graph, and what is the base for this? It's basically log a. Here also it was base. Okay, so and over here as well your a is greater than 1. So you see, we just told that inverse functions are symmetric about, or it's a mirror image along y is equals to x. Now if I have to draw this line y is equals to x, it's going to pass from here, right? So this is what you see, and do you see this is mirror image of this, right? Somewhat,
Yes,
at
sir.
least
Yes, sir.
roughly
Yes,
we
sir.
can understand, right? So this thing will convey us like, okay, basically a logarithmic function is an inverse of exponential functions. Okay, so we know this much now. All right. So what about logarithmic function? Now let's discuss more on logarithmic function. So if I have to write down here, okay. So now what do we see? Now log ax. So how do we define this first of all? Okay. So by definition, what about, so could you tell me what is the nature of a? A should be greater than 0 and a should not be equals to 1. Correct?
Yes, sir.
And what about x? X has to be greater than 0.
0.
Correct? That means what is the domain of logarithmic function?
So why should x greater than 0? Why
It's
should
just the definition, like whoever, whichever, like the mathematician who would have first come with this function, he told like, okay, this has to be something like this. Okay, so we have to take it in that way right now. All right.
Can't we take negative value? Log of negative
You
value?
take it minus log x. Okay, not minus log x, but you can have certain functions wherein, you know, I can restrict the domain of this function saying that log x square, and then I can define that only where x belongs to let's say from, you know, 0 to, let's say, minus infinity to 0. If this is the definition, then of course you will have something negative part also coming into picture, but we will slowly build up that. But right now, as per the definition, f of x is equals to log a, log x to the base a, where a is greater than 0 and a is not equals to 0. That means, okay, so we got to know this is the case where a is greater than 0, the graph what you saw here, right? So now we'll discuss what about when it is negative of that, right? Or when it is between 0 and 1. Okay, not negative. So what is the domain of logarithmic function?
0 to
0
infinity?
to infinity.
For this form. Okay, so if we change it accordingly, then it has to change. I mean, the domain will keep changing. Okay, but for this function, this is the standard logarithmic function. For this, the domain of f of x is basically what? 0 to infinity. Okay, so you have to pay attention to this. What about the range of this?
Okay, numbers. R.
R, or minus infinity to plus infinity, right?
Yes,
So range of f of x is R, correct?
yes, sir.
Sir, there we have told that x is greater than 0. Then how can we take 0 in domain?
No, I'm not including that.
Oh, yeah, yeah. Okay, sir. Okay, sir. Thanks.
Okay.
It's in that.
Okay. So now this is about general logarithmic function. We got to know what the function is. This is the basic definition. We have to keep it in our mind. And why this is important is because this is essential to find the domain of this logarithmic functions. Okay. Sometime you will have log a times, some big equations will be given. Then you will ask to find out, okay, what is the domain of this log functions, right? So at that point of time, this data will be essential to solve those kind of questions. Okay, so pay attention to this one. Okay, now we got an idea about the domain of this, and we got to know what is the range of the functions, right? So now, having known these data, now let's just a small graph for this we'll understand, and then we'll discuss some of the properties of log functions, and we'll do some kind of numericals wherein we are dealing with domain, and we will do the graphings of logarithmic functions. Okay, so pay attention with me for today. Okay, and this will be really essential even for your quiz as well, so pay attention. Okay, because we don't have another time wherein we can discuss you in depth these functions. So even if you don't understand, just be with me. Okay, and maybe after seeing the lectures and solving those activity questions, you might be able to understand when you rewatch this video. All right, so having known what is logarithmic functions, now let's see how these graphs are. Okay, like some basic graphs for this, like when we have this, we have this kind of nature of this graph coming up like this, right? So when log ax, where a was greater than 0. Okay, what about when a is smaller than, when a is between 1 to 0, how will the graph look like for log function? So that's going to look like something like this. I guess something like this. Okay, okay, where this is 1 and this is your log ax, where a condition is this. All right, so now this is how the graph looks like. All right, so what if I take negative of, if I, now I'll just build up here, what if I give negative log ax, then this will simply change its nature. It's going to be like this. Okay, right? So this is going to something look like this. All right, so now when I give negative log of x, so it's going to turn something like this. Okay, so negative log ax. All right, so this graph get tilted like this. All right, but do not get confused, this is not same as this. Okay,
That's
you will
looking like same, na sir?
looking like same, that is fine, but the magnitude will not be same. Okay, so it will be, you cannot say these both are equal. Okay,
Okay, sir.
okay, so now just we understood this basic graph for log and minus log x and log x. So now let's discuss some of the properties on logarithmic functions. Okay, and these properties will be helpful for solving your problems ahead. All right,
Sir,
We
those
will be doing
constraints.
activity also.
see, what I thought was like most of you don't know the things, so I thought like I'll just build up the things. I'll give my own questions here. We can discuss activity if we have time, but I don't think so we will have much time because I have a lot to discuss to
Yes,
you
sir.
on
Yes, sir. Even
logarithms.
we have to understand a lot.
Yeah, so pay attention with me. If you know something, it will help you out. If you doesn't know anything, just pay attention to what I'm saying. But of course, this is I'll be telling you so much that you might lose the track at some point of time. But do not worry, you can watch this video again and understand this. All right,
Sir, those condition a greater than 0 and a not equal to 1 is applicable for exponential also, right?
yeah, you saw that, right?
Yes, sir.
Yes. Okay, so now let's discuss some of the properties, right? So we understood what log functions is and how is that different from exponential functions, right? We understood what is the domain and what is the range. Okay, one more thing I wanted to tell about log function. So if this is log x, and if the graph for log x is something like this, okay. Can you tell me where is its asymptote? Can you tell me equation of asymptote here?
X equal to 0.
X equals to
Zero.
0, right? Okay. Now, if you have something graph like this, let's say a graph something like this, what about the asymptote for this graph?
Y equal to 0.
Y equals to 0. Okay. What if I say this graph is, okay, so we happily told e to the power of x is equals to 0. What will be the asymptote for this graph?
Y equal to 1.
Y equals to
1.
1, right? Because this is 1, and you will see at infinity its value will be 1, something like that. Okay, so here I just wanted to know whether you know the asymptote or not. So I guess all of you know, or if you don't know, we just discussed it. You got it now. So what asymptote is, we understood that. All right, so now let's discuss some of the properties on logarithmic functions. So what are the properties? Yes, do you have any doubt here? Sorry, your voice is breaking. Could you repeat again?
Sir, please explain what is asymptote.
Okay, so basically, okay, I'll just erase these things. So asymptote is at what value, or where does that graph tends to when x is going to an infinity, right? Right. So if I have to tell you some graph like this, so you see this when this is your log x to the base 8, right? Now you have it. What happens when x tends to infinity? It will give you some unique value, isn't it? Now if I, this will be some unique values you will be getting, and it's like you can say it's diverges when x tends to infinity, right? Your, if this was f of x, what do you see your f of x going towards? Even this is going towards infinity, right? And it will be somewhat uniquely being mapped, right? So it will give some values wherein, you know, like you will have a very unique values coming into here. Of course, even here you will have a unique values coming in. So how do we distinguish which is an asymptote, right? So you see this value when x tends to 0, okay, what happens to your f of x value?
It tends to infinity.
Okay, it tends to infinity. Then how do you say this is an asymptote? Will anyone take this initiative?
Truth is that it never meets that line, but it is tending to that line.
Right. So that's what it happens here. So basically, like when you approach this graph, like when you go to the 0, you never actually reach that 0 value, right? You never reach that 0 value, and you see this as you approaches to 0, this graph goes to infinity, right? So that's how you can, one way of understanding is you can understand this way, like when this function approaches 0, you see your f of x going to minus infinity, right? So that is one way of understanding it. Look at over this part, right? Your x is increasing, right? There is no limitations on this. Like you can map all the values of your x here, no matter what. You can say like let x go to 100 and so on, let's 1000, and you get some values. But here what you see is when you approaches this value, like when you go to the 0, like when you bring this function to the 0, like as x tends to 0, your f of x tends to minus infinity. So that means like when you are approaching 0, you are actually not reaching 0, but you see your function is achieving some values. Okay.
Okay, sir. Thank you.
Okay, somewhat you would have got it. So let's keep that as it is. Now let's discuss some of the properties of logarithmic functions. Okay. So what is the importance of this properties? It's basically this will be helpful for solving your questions, and these properties are derived from your very basic definitions only. So we will not be dealing with the derivations for this, but I just want you to know these are the properties, because this will be essential for solving your questions. Okay, so but I think most of you will be knowing this, the properties. So could you tell me what is this log 1 to the base a?
Zero.
Zero.
Zero. And this is basically whatever here a, as you know, a belongs to, or a is greater than 1. Okay, so we can keep this in our hand. This is applicable for even when you take a, when the base is half, still you will get this. So log 1 is 0.
Sir,
Mhm. Yes, tell me. This is not defined, right?
Yes, sir.
What about, so now you have it log
That condition A is
mn. So what about this?
Plus
Can you tell me the expansion for this?
Log
log
m
m
plus
plus
log n.
Log
uh,
m
log
base a plus log n base a.
Right? And here we have condition that m and n both are greater than 0, correct?
yes.
Yes, sir.
Right? Okay, what about this fourth one? Now similarly, this is in product form. Now log m by n can be written as,
Log m
Log
base a
Log
minus log
m
n base.
minus n.
right? So we know this as well, and we can simply say that m and n are again the same condition.
Yes, sir.
Fifth one, what about log a 1 by n?
Minus log
Minus log a by n.
log
A to a
n.
n. Sorry.
Minus log
Minus
n
log
to the
n
base a.
base a.
N base a.
Okay. So for those of you who are not able to understand what this is, just for time being, just keep it in your mind that these are some of the formulas. Okay. Now, what about
that what first conditions are a less than equal less than 1 less
Okay.
than 1. I didn't get.
Actually, I did an error there. Okay, this is
Oh,
the
between 0 and 1.
correct.
Okay.
Okay, now you have something like this. Let's say m to the power of, let's say, okay, let's keep this as capital M only. M to the power of n. Then what do you get?
N log m base a.
So I can write this
n log m base a.
right? So something like this. What about? Yeah. So what about if I say? So we understood like basic things. Now what about a log ax?
X.
Equal to x.
X.
Okay, equal to x. And what? Okay, so we just keep it as it is for time being. We can come into complication part of this later on. Okay, now what about this? Is we have something called change of base formula. So I'll just write down that
Log
here.
Log x
log
by
x
log.
Log a base
b.
b.
Okay.
Log a base b.
Okay, so now this is called change of base formula, right? So what we have done is we just log x and we took any base b, and we know that what are the condition for this b. Now
B
instead of
greater
a, we
than
can just
0 and not.
substitute b here. Yes.
Between 0 and 1 and greater than 1.
Same conditions as a
Same conditions for log, right? So okay, now what about log, let's say a to the power of bx?
1 by b log x base a.
Log x base a. Okay, what about, so I can also write this later on like this, ax to the power of 1 by b,
Yes, sir.
right?
Yes, sir.
yes.
Okay, now coming to 10th one, our 10th property, we can take it as, let's say m log ax. Now this can also be written as,
Log x to the power m base a.
so this can also be written as x log a m.
M.
So you see this thing got changed, right? So just keep this with you. This will be really handy while solving the problem. Okay.
The 9th one I didn't get that. Can you explain it?
This one.
Yes, sir. Yes, sir. I got the second one, second and third equation, the 9th one. But the first one, a log
This one, is it?
Yes, sir. Yes, sir. That's only.
Okay. So so basically this is one of the identity, but if you want to find out how this came in, I think I have given this explanation in the practice assignment solution. So you can, in the first question itself, you can see at the bottom I have given the proof for this. So you can just go through that. Okay. How is this happening is, again, I will have to write the proof for that, right? So you can just, in your practice assignment, you just go through that. It's very simple. You can just do it straightforward. You can just simply change the base and you will come to a conclusion for this part. Okay. So it's given in your practice assignment first question. At the bottom, I've given the proof for this. Okay. So you can just refer that. But for
Can
time
you
being,
put the screen little down?
little down, is it? Okay. This way. It's good.
Sir, complete identity on screen.
I didn't get, sorry.
See, I want to see all the formula once again.
Oh, you want to see all the formulas? Okay, fine. So yeah, this is all the formulas. So if you want to write down, you can take a photo or screenshot.
Yes, yes.
Yeah, good. Thank you, sir.
Okay, so these are some of the properties of logarithmic functions. Now we can discuss some of the questions. Okay, so now let's discuss some of the questions, and then we can switch quickly switch to the graphing part of this. So I'll be primarily giving more emphasis to the graphing, and I'm pretty sure all of you will learn how this activities and practice assignment is done by some or the other way.
Sir, so much of domain is there. I'm getting
Okay,
confused
okay.
in activity.
Yeah. All right. So much domain is there, right? So we'll take up some domain-based questions. So maybe we can do it here. So is it fine? Now should we move ahead?
Sir, yes,
Do you have any doubt? As if now, no doubts, right?
these are formula, just we have to keep in mind.
Correct. So yes, so if we know these many formulas, now let's quickly switch to some of the domain-based kind problems. Okay, so now if I have given a function log 2x plus 3, and let's say this is x square, yeah, just keep it as x square. Could you tell me what is the domain of this function? Quickly solve and tell me what is the domain of this function. See, one way of knowing is we always have to make sure that the definition of logarithm is not violated. Okay, and that is the only thing you have to keep it in your mind while finding the domain. All right. So what is domain of f of x? So those who are solving, solve it.
Sir, it means 2x plus 3 between 0 and 1 and more than 1.
So 2x plus 3, first of all, it has to be greater than 0, correct? And 2x plus 3 should not be equals to 1.
Okay, sir.
Right? It should not be equals to 1. And what about this? X square has to be what?
Greater than 0.
Sir, a real number, no?
Greater than 0, right?
Yes, sir.
Yes, sir.
So that is something we have to keep it in our mind. So these are the only 3 things by which we can find the domain of these functions. Okay.
Sir,
So
how
now,
it will be greater than 0, sir?
okay,
It will
now
be positive, all positive.
Right? Got it? So now we know this. So that means my x cannot have the values now 2x plus 3. I'm just looking at this part. 2x plus 3 greater than 0. So I can write down 2x has to be greater than minus 3, or x has to be greater than minus 3 by 2. Right? One data we got
Yes,
from
sir.
here, that
Yes,
x
sir.
has to be greater than minus 3 by 2, which is certainly not violating this condition. I mean, at least for the real part of, the positive real part for this. Now, what about this one? So this I can write it as 2x should not be equals to, this can be written as minus 2, or x should not be equals to what? Minus 1.
Minus 1.
Yes, sir.
So now I have this data from here. And from here, what all I can have? X square being greater than 0. So we know that x square, how does it look like? The graph for this? Something like this? Parabola, right? It's only at this value it is 0, and for no matter what x value you give, this is always going to be positive. Correct?
Yes.
So this x value can take all the things. Now, how will I find the domain? So from here, if I take out this part, I'll just draw a real line. Okay. What I do is I'll just draw a real line from minus infinity to plus infinity. Okay. And from this data, I can understand it can take all the values. If this was 0, it can take all the values except 0. Correct?
Yes, sir.
Also from here, I can understand it can take all the, it can take only values which are greater than -3/2. Right? So -3/2 means it's something -1.5.
-1.5.
So let's say it was something here. So this is -3/2, and it is not included. So it has to be greater than that. That means our graph has to be something like this.
Yes.
So now we have a common region. Which are those common regions? These parts. Right? Now let us see what all we can have. Now it also says that x cannot be -1. So that means our -1 was somewhere here. So if that is the case, that means our -1 can also not be included in this. Rest all will be there. All right. So now what will be the domain from this we understand. Okay. So now I just
-3/2 to infinity except -1.
no, even except 0, right?
-1. No?
-3.
-1
-3,
except
comma.
-1.
What about 0? Even 0 is not included, no?
Yes, sir.
Yes, sir. Yes.
Right. So even that is okay. So I'll just write down here. It's just to show that, you know, the intersection region. So this is the condition. Then I can say from, sorry, this is -1. Then -1 to 0 union. I can say 0 to infinity. Now you see, I know my domain.
Yes, sir.
How did we get this? I'll just summarize this again. First of all, I have to make sure that the domain, the function is not violated with the given, for the given function. So for this, for the given x values, for this, look at this. If I have to make this log function to be defined, I have to make sure that this is greater than 0 and this is not equals to 1. Correct? So this is as per the definition. Also, I have to make sure that this is greater than 0 always. Right? X square is always greater than 0. So we know that x square, when it was greater than 0, at 0 it will give me 0, and no matter whatever x value I take, it will always give me a positive value. So this is always positive, right? So that data I had. So now I, from these three information, I got the x values, 3x values. So what I did next, I just drew a number line. And since these three regions are given, all I have to do, or just three informations are given to me, all I have to do is just find the intersection information of this, right? So what I have done is I have just drew a number line, and then whatever
Sir,
the data
I have confusion in the number line. You have drawn except 0 toward both the end. This is the domain of x square.
Yes.
Domain of x square. Yes, for this x square.
But we are taking only positive side of the x square because x square should be more than 0.
X
square should be. You are taking x.
Okay,
sir.
Okay, sir. Right. So all right. So we got this. I'll mute everyone. I guess the voice is. All right. So now we can see that from here, we got this info, like this can take all the negative x values and positive x values except 0 from this part, right? And from here, I got an information that x has to be greater than -3/2, or x has to be greater than -1.5. So that means this part is coming into picture. Also from here, I got to know that x cannot be -1, so which is somewhere here. So if I have to sum all these, what are the intersection region I get? Of course, this will not be in my intersection region. So we can simply omit this, right? And then you will have this. Now intersection of all these, you will find this part coming into picture. So that is -3/2 to -1, union -1 to 0, union 0 to infinity. Okay. So now this becomes the domain of our f of x. All right. So now let's do one more problem based on domain, and then we can discuss some more problems on graphings and domains. So I hope you understood this question. So this was fine for all of you, right?
Yes, sir.
Yes, sir, it was clear.
Okay. Now tell me, I have another graph, x -1, x -2, and I have x square plus x. Tell me what is the domain of f of x. You can keep solving, solve it, see what do you get. Or likewise, even I'll solve it here so that we can do more problems. Okay, so the domain of f of x, again I have to make sure the same thing here, right? So that x minus 1 times x minus 2 has to be greater than 0, and x minus 1 times x minus 2 should not be equals to 1, and x square plus x should always be greater than 0. Correct? So now this is the condition given to us here. Okay, so now when will this graph be greater than 0? So if I simply just plot this, how will that plot look like? So if this is 1, this is 2, how will the graph look like for this? Something like this, parabola opening upward. Yes. Right? So, and this has to be greater than 0. That means I can only take these values, right? From here, my x can only belongs to what? 1 to, sorry, minus infinity to 1 union 2 to infinity. From here, I can draw this information. All of you are with me?
Yes.
Okay, so from here I can draw this information that x has to be something like this. And how did I come to a conclusion? Because I simply drew the graph for this, and I know this when the graph tells me that between 1 and 2 this function will be negative, and that is something I cannot take. And I cannot take 1 and 2 as well, because when I substitute 1 and 2 it makes 0, and this function has to be greater than 0, right? So that's why x has to belong to this region only, correct? Okay, so having known this part, now let's move to the next one, this part now. Okay, so to solve this, how do we do this? So let's just simply expand this. So I can simply write this.
We will get x square minus 3x plus 1.
Okay, so if I expand this, so I'll get x square minus 3x plus 2 not equals to 1. So this will give me x square minus 3x. If I bring it here, so this will give me plus 1 not equals to 0. Correct?
Yes, sir.
Okay, so how will the graph look like for this? What about, could you tell me the graph for this? So if I have to draw the graph for this, so minus b by 2a will give me what? So this is going to give me 3 by 2. So that's going to be 1.5. So my vertex is at 1.5, which is somewhere here, right? 1.5. And I know my y-intercept is 1, correct? So my y-intercept is 1 here. Okay, so I know about my vertex and I know where it is intersecting. Okay, so what else information I have? What is the discriminant for this? B square minus 4ac. So this will give me 3 square. So that is 9.
Root 5.
For root 5, is it? So it's greater than 0, isn't it?
Yes, sir.
It's greater than 0. That means it will cut at 2 points, right? So that will be 2 points somewhere, isn't it? So all I have to do is just find out those 2 points, correct? So as you told, this is root 5. So of course, then I have to make sure that these values are not included. That means the roots are not included. Rest all it can take, isn't it? So now if I have to solve this quickly, then if I have to find out the roots for this, then it's going to be some. What did you could you quickly solve this and tell me what is the roots for this?
So we can directly find from there because
3 plus root 5 by 2.
3 plus minus root 5 by 2.
3 minus root 5 by 2. These are the roots.
You got the roots, is it?
0.382 is one root, sir.
0.382
and
382 and another
2.618.
2.618. Okay, so that's going to be here. So 0.38 and this is going to be 2.61. Okay, so as if now I take these as roots for this. So from here, what I can understand is my x belongs to R, right? But it does not include 0.38 and 2.61. Are we fine with this?
Sir, we can
Yes.
find the root directly also because it is factor from.
No, but you have this, no, when you, it should be equated to 0, isn't it?
Or you can do like that, x not equal to 2 and then x not equal to 3.
X not equal, no, it's not done like that. It's basically, why do you do that is, it's just because you know, factorization makes it easier, and then equating it to 0 becomes easier. That's why we go with that. Okay, never do this you know, comparing with 1, like bring this and then compare with 1. You can do, but it becomes a bit difficult task, isn't it? Now you will have to really think of like what value you will have to substitute here, so that you know, this becomes
Not equal to 1.
not
Yeah.
equals to 1, isn't it?
Oh,
But
yes,
when it is
yes.
0, it's very easy to do that.
Yes,
Right?
yes.
Okay, so now I hope you understood. Here, from here we got this info that x belongs to R, but it cannot take these two values. So you're with me as if now?
Yes, sir.
Okay. From here it says x square minus plus x has to be greater than 0. So now if I have to factorize this, this is going to be x and x plus 1 greater than 0. So if I simply draw the quadratic equation for this, this is going to be 0 and this is going to be, let's say, minus 1 here, right? And this graph is going to something look like this. And it says it has to be greater than 0. That means, again, I cannot include this region, right?
Between minus 1 and 0.
So again, I can say that x belongs to
Minus infinity to minus 1 and 0 to infinity.
Union
0
to
to
infinity. Now I have these regions. Now what do we do with these regions, right? So again, we'll draw a number line and understand that. Okay.
Sir, minus 1 is included, no?
No. When you include this, it will become 0, minus 1, correct? And we have to make sure it is greater than 0. Okay. So now, having known this, now we have to draw the number line and just try to find out what are the intersection points. Okay. So now let's take this. So since it says minus infinity to 1, so I'll just draw those numbers. So this is
minus
0.
1, 0, 1, 2.
Yeah. So 1, 2, and then what do we have? Again,
Minus
minus 1
1.
we can take. Okay. So now these are the points, and of course this is lying in between. So we can take this 3 as well. So now let's understand this. From here we have this regions coming into picture. So now we can see that minus infinity to 1, right? So I'm drawing this one. I'm drawing the conditions for this. So this is going to be something like this: minus infinity to 1 and 2 to infinity, right? So this is the point we get, right? This is the region we get from this part. And why do we do this? Because we need to find out the intersection region, and that only becomes the domain for this, right? Over here it says all the value, but it cannot have values between this, right? So from here it says all the values. So I can take all the values over here, right? And what it cannot take? It cannot take
0.38 and 2.61.
So it cannot take 0.38 and it cannot take
2.61 between 2 and 3.
Yeah. So it cannot take 2.61. Now, okay. So now I from here, what do I understand? What are the intersection region? I can find out the intersections region are this, like only this part. If I have to use some other color, just give me a minute. So from here, I know that my intersection regions are only this, right?
Yes, sir.
Yes, sir.
Right?
Yes.
Okay. Now let's take the third condition from here. I'll use
that 0.38 to 2.6 area we cannot take, no, sir.
That value we will not take, because here it says, no.
Put right there.
That is not included. Actually, this part is not included. That's why I did not give it a red mark. Okay.
Okay, sir.
Now let's go to this part. Maybe I'll check some different color now. Okay. So here we have minus infinity to 1. Now where does this region lies? Minus infinity to minus 1, right? So that's going to be, and that minus 1 is not included. So that's going to be something like this, right? So this is minus 1 for me, and 0 to infinity. Now where is 0? 0 is here. 0 is somewhere here. So 0 to infinity, right? So this is something we get. Now what are the common region? That is something we have to find out now, okay, to find our domain. So maybe I'll use different color here.
Minus infinity to 0.
So from here, what we can say is
minus infinity to minus 1.
So you see that I cannot have this region, correct?
Yes.
Right? So I cannot have that region. So my domain will be what? My domain is going to be domain of f of x is equals to, you see that this is going to be minus infinity to -1, and -1 is not included, correct? And then
Correct.
I can have from the earlier graph,
0 to
0.38,
0.38.
0.38 to 1.
yeah,
Union
then
0
I
to
can
0
have
to-
union 0 to,
0.38.
can I take 0?
No,
No,
sir.
no.
No, sir.
No.
Open bracket.
Yeah, open bracket, right? So I can take zeros, but I can take only up to
0.38.
so 0 to 0.38, correct?
3.
Union 0.38
0.38 to 1.
1, correct? Then union, what else we can have?
2 to 2.6.
Wait, yeah, so no, I can, yeah, correct. 2 to 2.6,
2.61. And
union,
union 2.61 to infinity.
perfect. You see, this was very complex, right? Now, if
Yeah.
you can do this, I think you can do all kind of activity questions given, right? Related to domain. So I hope this is fine, right?
This 2 to 2.61 union 2.61 to infinity. Can we not tell 2 to infinity?
No, but 2.61 is not included, no?
Minus 2.61 we can put it, no? That's another way of telling.
Sorry?
2 to infinity.
You can say like this, 2 to
Minus
infinity, but what is not included? 2.61 is not included. This is another way of writing. You can write it. Okay. Okay. So I think this is all good with the domain thing. Okay. Could you tell me what is the range of this function?
0 to infinity.
0
to infinity.
Why 0? Only 0? Why not minus infinity to infinity?
So we have x square.
We have x square. Okay. So could I not say this? Okay. So we'll come to the range part once we are doing the graphings. So as if now we can restrict ourselves for that. All right. So yeah, because the graph will be really essential for finding the range and all that. All right. So I guess finding domain is easy, and we know now we can switch to the graphings. Or do you have any doubt, or you think where you need explanation here anywhere? Anyone? No doubt. Okay. So we can start with the graphing for this, and graphing is kind of essential again for logarithmic function, as you would have seen.
Sir, where it is application of this inverse and exponential sum?
You want to know the application real life?
Yeah.
So you have it in your questions. You can practice your this thing. Maybe like your practice assignment questions, and even in the graded we have given some of the questions. You can practice that. Else, if you want me to like right now to tell you, so how does the graph look like for this logarithmic function? So it's something like this, right? So if I am a framer of a question and if I see something not like this, a graph like this, right? So what I can do is I can play around with the domain of this. Okay. So if I can quickly think of what its applications are, so you see the growth is very much retarded. It's not like exponentially as it is going, isn't it? So if you want to know any applications for this is, this kind of logarithmic thing, it has got applications in biology. So that is something I can recollect right now. Maybe like you can think of some kind of growth curve of some microorganism, right? So that will have some kind of growth like this. But of course, it's not going to be always rising, it becomes constant. So that is something. And like when we are giving any application, so we always have to restrict it, right? So we always have to restrict its domain and give a questions. So you will find like in nature, when you see some kind of things, some, let's say a growth of a petal, or let's say a growth of a microorganism, which is happening from day one, okay, and it goes up to certain like this, and you see that the growth is this kind of curve is not an exponential, right? And it's not a polynomial either, right? You cannot have any trigonometric functions coming into picture. So you see, log will find its application in that part. Okay, so the growth is happening like this. Okay, so which function to use? So you will come up with one of the functions saying that, okay, it might be a logarithmic function, and you fit the model for that. Okay,
something like saturation.
Saturation, you cannot say, it's because it's increasing function. No, logarithmic function is an increasing function, so it never saturates, isn't it? So that's one thing you can think of. Another thing is you can use it in somewhere in stock markets as well, when not the entire domain of log, but yes, restricted domain. So those kind of, you can use that models as well, because sometimes the stock price, if it's falling, then how is that falling part is happening? Or like, let's say a growth is happening, so what is the, in which function, what is the nature of that growth? If you want to find out, then again there you can find its applications.
Log returns. Log returns are used, sir. You have said the stock market. Log returns are used frequently.
Yeah, so you can think of that as well. And if you can ask me in, like, let's say like chemical engineering aspects of this, then you can find out something called LB plots, wherein log function is very much essential there. So these kind of things. And of course, logarithm is always used in solving a complex problems like exponential. Like, let's say you have let's say a stock market whose price is exponentially rising. Okay, for example, take IRCTC. Its price is, I mean, its growth is exponentially rising right now. So now how do you predict this model, right? So you think of, okay, like, okay, this is something going to be like this, and what is this a factor? But see, whenever you want to find an exponential function and these parameters, you always need log, right? So you take log on both sides. So log will find its application in solving a questions as well, right? So that kind of thing happens, right? So these are certain things wherein you can find applications. For more, I think you have been given in practice assignments and also in your graded. You'll be able to appreciate that there. And I think you will also find it in some of the previous year's paper also. And yeah, these kind of things. So, okay, you can keep this. And I think this can be a good motivation for you to study logarithm. Okay.
So we can say the share price of a Reliance Communication is logarithm.
Yeah, you can restrict the domain and say, right? Okay, so now let's go to the graphings of logarithm.
Sir,
okay?
I have a doubt.
Mm-hmm.
Sir, the procedure was for domain, we first have to find out that the properties are not violated, right?
Correct. And that's the only parameter you have to keep it in your mind while finding the domain.
But in case
not the properties, but the definition. You have to make sure it is defined.
Okay.
Yeah.
So is there some cases when properties are not met? Like it is getting violated, then what?
Then you will not consider that in your domain.
Is that possible that the properties are not met?
No, I don't think so. Because see, when you find a domain, you have to make sure that the function is defined for that values of x, right? So then why will you find out where it is? Okay, so why will you, I mean, there is no point giving questions like, where its definition itself is violated, or you might be asked a question like where its definition is being violated. Okay, and basically you exploit that property, in fact, isn't it, to find out your domain. So that's the thing you do. I don't think so like you will be asked any questions as such. Okay, so no worries on that. Okay, so now let's do some kind of graphings and see what are the popular questions which you can expect. Okay, so if you have been given, so you are very much fine with certain graphs, like let's say we know a logarithmic graph, something, this is for log ax, where a is greater than 1, right? And this was going towards infinity. This is 1, right? And then what about log? Now, okay, let me do it part by part so that you will understand it better. So if I have to take the another thing here, if I take second one, how will the graph look like for log x square? Now we are getting into some kind of complications here. So how we will do this? Could anybody assist me doing this?
So we can use the property to bring that 2, 4, right? So it will become like a stress factor for that.
So this is going to be something like this and like this. Sorry. Okay. This is the graph for log x square. How did we understood like this is the thing? Okay. So now whenever you do questions like this, okay, so you first, whatever function is given, draw the graph for that. All right. Then you will find it very easy. So now if this is 0 and this is your x-axis and this is your y-axis, how will the graph for x square look like? Something like this. Right? This is the graph of x square. Isn't it?
Yes, sir.
Okay.
Yes, sir.
And what about log x? As now you see after this is increasing, correct?
Yes,
so
sir.
now I have to look for this one, log x square. So how will that look like? You see at 0, log x is not defined. So it will go something like this. And we know log 1 is what? Log 1 is what?
0.
So log 1 is 0. So that's happening here. So I can simply say that this is the case. Now you see this as x value increases. How is this function doing? So you basically have to look at this part, right? So you see this is increasing, right? So as this increases, don't you see that log x square also increases? I mean to say, what is log 10? If this is to the base 10, it's 1, right? What about log 10 to the base, log 100 to the base 10? 2. Similarly, log 10 to the base, let's say 10 to the power of 5 is going to be 5.
5.
So in other words, as this value is increasing, even this value is increasing, right? So log of something, if it is increasing, then log as a whole is increasing, correct? So if this part is increasing, then our log function will also increase. So it will go like this.
Yes, sir.
Correct. But you see, it is not increasing as this function is increasing, because you see this is 100, but log of 100 is 2. Log of 1 lakh is just 5, right? So you see this part will not go something like this, isn't it? It will be flat, but it is increasing, isn't it? Clear? Okay.
Yes, sir.
Yes, sir.
So if that much is clear, let's understand the other part of this. Now, what about as x is increasing, minus x part? So you see, when I give log minus 10 the whole square, this will give me what? 2.
Yes.
Right? So because why? Because this I can write it as log 100 and this can be written as 10 square. So log 10 square is nothing but 2. Correct? So that's how I get it. So again over here, so no matter what negative values you are giving there, okay, so again I can say at 1 it is 1 and at 0 it is asymptote. So you see this value is increasing, isn't it? This function is increasing. So if this is increasing, my log will also increase and it will increase towards this side. And why is it this side? It's because we are taking negative x, right? Negative x square. That's why this is bending towards this side. Some of you might have confusion. Okay, why not it is going this side?
Yes, sir, because it's squared, so negative won't have any
it's because there. Yes, it's because you are taking negative x. That means as x increases, what is happening to your this part? This is also increasing, and that is increasing towards this direction only. No, that is not happening this way. All right, so that's why this curve comes out to be like this. So log x graph is this and x square graph is this. So log x graph is not just this, in fact both these and this. Okay, clear?
Yes, sir.
Okay. See, I'll build more complexity here, so pay attention. So this is fine.
Yes,
Any
sir.
doubt? No doubt?
Yes, sir.
Okay, clear. Then let's go to the next part. So maybe I can erase this only and I can build up here. Now you see, so maybe we can take another function here. Instead of x, I can take it as mod x. Okay.
Sir, suppose if odd would have been there and a power would have been suppose
I will
minus
come
10
to
to the
that.
power 5.
I'll come to
then-
that. I'll come to that.
Okay,
I'll
sir,
give you
okay.
up to x to the power of 11 as well. So be with me.
Okay,
I'll
sir.
build the
Okay,
complexity. But let's go in a step by step, okay? So that everybody can understand this. What about mod x? How will the mod x graph? So whenever you get a question like this, just what is that log of this part, right? So you have two functions. So one is mod x function. So draw the graph of mod x. How will the mod x function look like? Something like this, right? So this is going to be your mod x function. Now what about log of mod x? So now again same way. See, this is increasing this way. This is increasing this way, correct? So as my x is increasing, this value is increasing. So now I can happily say that, okay, at log 1, so it will be 0. So this function will go something like this. Correct? So this is going to be my log mod x graph. Not this. You're saying that? Able to understand?
Yes, sir. So whatever that there in x, and it will get a bit reduced from that, right?
From x square.
No, suppose there log mod x is there, and whenever we take log to the, whatever is given, and then the value of that is reduced, it gets flattened a bit. Then the mod graph. Can you say like that?
Could you come again?
I mean to say that suppose in x square there was, so when we take log, the value gets decreased, and here when we take mod, when we use a log in mod, the value get decreased. Can we say like that?
Still the value will be decreased. Why? Because see, when you are giving, in fact, this will be more flatter like this compared to your log x square. That if that was something like this will be for mod x, log mod x. Right?
Okay. And what about x, log x?
Log x will be similar to this only, but see, mod x is something like this, no? So if you just take log x, so log x will be just this part, not this, just this part, not this. Isn't it clear?
Yes, sir.
So I'm not getting the difference between mod x and x.
Okay, I will tell you that part, and then we can build our complexity more. Okay, so what about the graph for log x? How will the graph look like? Something like this?
Yes, sir.
Why? Because x is always positive for me. Right? X always has to be positive. Now what about the moment I give it mod x? Correct. What happens when you give x equals to -1? This mod function will make it 1.
Yes, sir.
At -1, this mod function will make it 1 and serve log 1. Correct. So log 1 is what? 0. And if I'm coming from this side, so what you see, log 0 can also be. So can I say that, okay, this graph will be something like this? What about log of -2?
Log 2.
Log 2, right? So log 2 will be here, no, somewhere.
Yeah.
Right. So if this was, okay, if this was log 2, let's say this was 2 and this was your log 2, right? What about log of -2 modulus or log of -2 modulus? It's going to be log 2 only, right? So that's going to be somewhere here. What about 3? So this is going to be log 3 will be, let's say, somewhere here. Yeah. So let's say this is log 3. So if I have to give you log of mod 3, so what is log of mod -3? So if it is -3, that will be somewhere here. Okay, basically this graph did not go that well. So basically like this. Is it clear now for you? How will the
Yes,
mod
sir.
x graph look like?
Yes.
Okay.
So we can ignore that left hand part, sir. We can only take the right side.
For graphing?
Yes, for log mod x.
No, you have to take both. Actually, for mod x, both the graph, I mean, this is the graph for mod x. You will have to take both
X
the parts.
value in log x can be negative also, no, sir?
Sorry?
X for log x only. It will be a real taking only
case,
positive number.
So could you tell me what is the domain for this?
All
Real number.
Yeah.
All real number except 0.
Yes, sir. Yes.
Yes, sir.
Right? So you see this function is defined for all r, but it is not defined for 0. And you see, so what do you mean by log function is defined on r? That means you will have at least one output for that graph. So when you take any value of x, you will have definitely at least one output for that, isn't it? And we say let's say a log of -100. So you will have some output here, right? That's what it means. But what about log 0? The moment you give 0, it will become not defined.
So, sir, this function is a minimum function.
Sorry, which function?
Log mod x.
Is what function?
A many one function. Can we say like that?
Minimum.
Many to one.
Many to one.
Many to one. Okay, many to one. How do you say that many to one?
When there are two input and they give one output.
So you can say like this. So if I give it as -1 and 1, what do you get output? 0.
Yes.
Okay. So now on this, let's just
Only for mod x, many to one.
No. Even for log x square.
Yeah, log x, sir.
You will have
not
many
for
other
x.
cases.
So for all even multiplicity, sir.
Log
Okay,
x means we will have 1 to 1, sir. No?
Sorry?
We will have 1 to 1.
Log x is 1 to 1. Yes, that is definitely right. But log of mod x is not 1 to 1. If the domain is R, where 0 is not included, then it is not 1 to 1. But the moment I restrict this, I say your domain is, I'm restricting your domain and I say your domain is from -infinity to, let's say, 0. Is this 1 to 1 function in this domain?
Yes, sir. Yes, sir.
Yes, sir.
Right. So do pay attention to domain. Okay.
Sir, in
Okay,
log
now-
x, we won't take. There won't be any graph in left hand side, right?
In log x, no, you will not have it in the
So
log.
we will have in right hand, so it will be 1 to 1 only.
And why? Because see, for log x, what is your x? What is the domain of your x? X has to be greater than 0.
Yeah.
So there is no concept of negative x coming into picture. But
Yes.
look at for this one. What is the domain for this? R except 0.
Yes.
Right? So even negative x is included. That's why this graph is there.
Yes, sir. Okay.
Clear? All right. So now we understood this. Could you tell me what is range of this function?
-infinity to +infinity.
So range is
-infinity to 1 and 1 to
1.
infinity.
1.
Except 0.
No. Yeah. So basically R, no. Range is R. What about domain? Domain is R.
Domain except 0.
0 except 0. Yeah.
Okay.
Range will be all.
Range will be all R. Yes. So now you know that other standard question what we ask in your exam.
So
it's like,
how the range will be R? It is 0 to infinity, no?
No. You see this graph? This is tending towards -infinity, right? And this is going towards +infinity. You see the y values.
Yeah.
When you seeing the range, you see the y values, right? Look at this graph. Where is this going? What is the maximum y value or negative y value it can take? -infinity.
So what for range we consider the y values?
So you take 0. Let's say 0.5. You will have some negative f of x. Negative f of x value you will have, right?
Yeah.
Correct.
Sorry, but
Correct, sir. Correct.
But +infinity, how it occur? Like this graph is bending. So how +infinity in y-axis?
Okay. You tell me what will be 10 to the power. So now you tell me what will be the value for this? If this is, let's say, something, how many zeros? Maybe like 5 zeros. What will be the value for this?
50, like
So it's going to be 1 lakh, right?
5. Yes.
So see, what happens is this is your x here, right?
Yes.
So as x increases, what is the value of your log x? Even this is
By
increasing.
yes.
But it is increasing slowly, but still it is increasing. What happens when this goes to some,
Infinity.
some infinity or a light year?
Yes, sir.
What happens here?
Then
It will be
answer
light
will
year,
be light
right?
year. Yes.
Here.
Yes. Thank you, sir.
Okay. Yeah. So fine. So we know this right now. Okay.
So,
So
what is the base of log modulus x?
Log?
So modulus
This
x.
is 10. You can take anything, but you have to make sure. Standard way we are saying that this is a, where a is greater than 1. Okay.
Okay, sir. Okay.
Okay. So now, having known this, now we know what is our domain, we know what is our range. We also know our standard question, what we ask, whether this function is increasing from this to this. Is this function increasing from 1 to infinity?
Yes, sir.
Yes.
Increasing.
Increasing. So this is some standard question which we ask. So the only solution for this kind of thing is just draw the graph, rest all everything will be done, right? Okay.
And sir,
so
how it can be negative in mod?
how it can be negative in mod in the sense, this part, how is this part coming? Is it? I didn't get. Can you come again?
So this part which is going towards negative x-axis, negative y-axis.
This one?
Yes.
Okay, take your calci and use this. Log of minus 0.002. See what value you get. Or let's say this is, yeah, just keep it like this. You see what do you get? Or let's say you 10 to the power of minus 2. So what do you get for this?
-2, sir.
10 to the power of minus 2. So 10 to the power of minus 2, your x value is 10 to the power of minus 2, which is 1 by 100, right?
Yes.
So you get minus 2. Where is your minus 2? That will be somewhere here.
Yes.
And this is 1 by 100 means 0.01. So 0.01 is giving you what? Minus 2, which is going to be here.
Yes.
Understood?
Yes.
Okay. So now, having known this, now I told you what are the standard questions which can be asked, something like this. Now let's build on some complexity on this graphings. Okay. So now let's see what all we can do with this graphs.
Mod
Okay.
of log x.
Log.
Hello.
Yes. Now could you tell me what is the graph for this?
Excuse me, sir. Hello.
Yeah. Hi.
Sir, I have a doubt in the previous problem.
Okay.
Sir, it is similar to like in the qualifier exam. Sir, can you please switch to the previous slide?
Actually, I erased it. I don't know if I can.
Okay,
I cannot undo as well. So could you tell me?
Sir, in log mod x function, when x is to the left of y-axis, is the function increasing or decreasing? Sir, because sir, इसमें doubt what I am getting, when x is moving towards the negative infinity, like it is decreasing, but y is increasing, so it must be decreasing function.
Hi, I got your point. What the question which was asked in the qualifier?
Sir, and in the qualifier, the answer to that problem is wrong. Matlab, I have marked all the answer, but they have not shown.
Don't worry, you will get marks for that. And we know, actually the wrong key has been sent. That is not a problem at all. If this is the case, if let's say something like this is happening, so of course this is increasing or decreasing part. Could you tell me?
Decreasing.
Clearly it is decreasing, but in the option it is given as increasing. So we have made sure that that is not happening. Don't worry about it.
Intuitively it seems like it is increasing, but actually it is decreasing.
Don't worry about that. That we have considered. And also there was one question like aspirational district.
Yes, sir.
I don't know
Yes,
if
sir.
you remember or not. The
Yes, sir, yes.
first part when you had that f of x divided by g of x thing, right? then how many roots do you get, right? How many real roots you get? Some of you have given answer as 2, some have given answer as 4. Both the answers are right. Okay, so no
Okay.
worries about that.
Okay, sir.
Yeah. Okay, so now let's come to this part. How will the graph look like for this one?
It will be log x except the negative part. Negative part won't be there.
Okay, why it will not be there? Let's see that. So
Can
log
I
x. Please go ahead. Please tell me how to go ahead.
firstly we draw log x graph?
Correct. So maybe like I can draw that something like this.
Yes, sir. Then we remove the negative part.
Why negative value?
And then we take the image of it in the x-axis.
Perfect.
Yeah. So
Something
this is
like
the
this.
graph of mod of log.
Nice. So you know this. I think then you can solve one question of your quiz too, if you know this. So good. So it's good now. You know the graphings.
So why is it getting the image of the y-axis? I don't understand that.
Okay. So who was that who was telling it? What's your good name?
Aditya, sir.
Okay, Aditya, and the person who explained that will be the negative value. What's your good name?
Sir, me?
No, not you, not
It
you.
was girl.
The girl.
Sir, Sonali.
Sonali. So could you tell me how did you get this part? Could you explain, Aditya, like how did we get this? Actually, it was supposed to be like this, right, Aditya?
Yes, so that part I got
like
it. You have to eliminate the negative part, but
so Sonali, could you
take
tell
the
me?
mirror
So Sonali will explain you that. Sonali, could you tell why this is coming but not this? Sonali, are you here?
Yes, sir. Sir, I learned it from the transformation of graph, so I used it.
Okay. So all
I
right.
think I can explain.
Okay.
Sir, because log x is taking only positive value. When it is 0 to 1, the instead of taking
Okay, so we can take this as 0.5. For 0.5, let's say we were getting something like -1.
-1. Okay, sir. So automatically -1, y mod -1 is 1. So it will go upward.
So it will go upward. Right? You got it, Aditya, now?
yes, sir. Got it, sir. Got it.
Okay, perfect. So now we understood this as well. Now let's understand this much more better. Now we got this. Now I'll do one more question, which will be mixture of your polynomial and logarithmic. And we'll do one more questions on this, some more like composition of functions, and we'll see what can be done next. Okay. So now let's say if you had a function f of x is equals to log of x minus 1, x minus 2, x minus 3, x minus 4, x minus 5. Okay, like we didn't make up to 11-degree polynomial, so let's stick on to this for time being. Okay, now we have to draw the graph for this. Okay, so to do this kind of thing, as I told you, whatever is there inside this log function, we'll first do the graph for that, and then we'll see how does the log look like. Okay, so now you see that how will what is the degree of this polynomial? If I just take this
5
degree polynomial, and it is odd.
Positive.
Leading term.
It is odd and the leading coefficient is positive. So the graph has to go something like this.
Yes, sir.
Correct?
Correct.
So now
sir.
let's say this is 1, 2, 3. Okay, maybe I can give some space and then do. So this is 1, 2, 3. It's going to be 4, 5. Okay, I'll mute everyone. Okay, so now I have this. Now if I have to draw the graph, now you see this is going like this, right? Now look at this part. At 2 it has to go something like this, at 3 something like this, 4 something like this, 5 something like this. This is what we get the graph for this part of the polynomial, right? Now see, it is saying log of all these, right? Correct. So now we will understand that. Now we will understand that how is that log function look like for this graph. Okay, so if I have to, and you can try this in your Desmos later on, so that you will not have any confusion. or like you can verify whether what I'm teaching is right or wrong. So you can just do that for your understanding purpose. Okay, that will boost your confidence when you're doing that with Desmos or something. So now you see that we know that log function, now when you take the product of all these, right, so it has to be positive, isn't it? So now you see this is positive over here. That means my log function will be defined for this region, for this region, for this region, and this will be defined only for this region, right? So what do we mean by this then? When I give log 5, when I say x equals to 5, then what will be my graph look like, f of x? At x equals to 5, what will be the value of f of x? Could you tell me?
0.
Zero.
It will not be
Zero.
defined.
Undefined.
Undefined.
Not defined.
So this will go something like this. At 5, right? At 5, it will go something like this. Now look at this part. But this is increasing thereafter, isn't it? So for 5, it is not defined. But for, let's say, if I had given, if that was 5, but for 5, it was not defined. So this graph will go something like this. Clear? I'm not sure what this value is, and I'm not worrying about that.
I didn't get how it's undefined at 5. It should be 0, right?
Log 0 is not defined.
Log 0 is not defined.
Oh.
Right. So log 0 is not defined. So that will go something like this. And that this part after here, should it go this way or this way?
It is increasing, right? So,
so it has to go this
increasing.
side. Okay. And I know for this part, my f of x will not be defined because this is negative, right? So I don't have to worry the values in between 4 and 5. But what about log 5? Oh, sorry, what about log 4? Sorry, when x is equals to 4, what will be your f of x value? F of 4.
0.
Again, it is not defined.
Again, it is not
Not
defined. So I can simply say like this. Clear? Okay. And what about at 3?
Not defined.
At
At
all
again
critical
3,
points, it is not defined.
but it is defined in this region, right? So my graph over here, it might bend like this. Okay. Maybe this peak won't be there, but yeah, something like this we might get. Clear? Clear? All
Yes,
of you
sir.
are with me right now. Can I
Yes,
say
sir.
it is going like this? I cannot say because this
No.
part was negative. So it has to bend
So
like
there
this.
will be gap in the graph.
Yes, there will
Yeah,
be a
it
gap in
can
the
be.
graph. Okay, so now you see this part understood. Again, in this region, my log function will not be defined. Correct?
Yes.
Now coming to this part. What about log 1?
Not
That
defined.
is also
Not defined.
Log 1 is not defined, so I can simply say this. Like this, it will be going as an asymptote. What about log 2?
Not
Not
defined.
defined.
Not defined, so it will go something like this. And again, this bending has to happen like this. Why? Because these are only the positive regions. That's all.
Sir, why you bend it? Like for 5, it is increasing. And for all this, it is bent.
That's what you have to understand. Look at this part. This is the graph of this, whatever is there inside, right? This blue color, isn't it? After 5, you put whatever value after 5. It will always give you positive value, right? After 5, no matter what value you give, like after 5 means 5, 6, 7, I mean 6, 7, 8, 9 up to infinity. You give any value, it will be increasing only, right? So when you take log of increasing function, the log will also be increasing, isn't it?
Yes, sir.
Right? So you recall that when we drew that log x square graph, how was that? If this was x square, our log x was going like this. Why was it going like this? Because this was increasing overall, so this also has to increase, isn't it?
Yes.
Yeah.
Sir,
So
one
that's
more
how.
doubt, sir. And sir, here the graph which we drew earlier, the green part, there 2 to 3 and 3, 4 to 5, it's decreasing. But here in red also it's getting decreased, sir.
That is not a problem.
Why we avoid that 2 to 3 and 4 to 5?
2 to 3 and
4 to 5.
2 to 3. Okay, because you see, in between 2 to 3, no, between 2 to 3, you put any values, let's say 2.5, this will become negative, and log of negative is not defined, right?
Oh, yes.
Right? That is why
Yes.
you see this gap. Understood?
But still it's giving negative, na, sir, in red part, sir.
See, f of x can be negative, but log of negative is not defined. F of x can be negative, but log of negative is not defined. Got it? Not very much convinced, but yeah, still understand this. Look at this part, log x. Okay.
Yes. Yes.
You see, this is your f of x. F of
Yes.
x equals to log x. You see, but x is always greater than 0. But the moment you take 0.01, what will be your f of x value? F of x of 0.01? Can I write this as 10 to the power of minus 2? So this will give me minus 2.
Yes.
So that is something like this. So that's what I'm saying. Your logarithmic function, log of negative is not defined. This is not allowed.
Yeah, I understand this, sir, but still.
Not able to take it, is it? You will take it very soon.
Sir, here, it means x value only, na, sir. Sir, here also we are, it's getting.
Don't worry. I know it's a lot of thing has happened, but keep practicing. You will be able to understand this. Okay.
It's simple only, sir. Here, it's the green part 2 to 3. It's a negative. Why x will be positive there, no, sir? 2
no.
to 3.
Between 2 to 3, you see your f of x value is negative, no? Sorry, this value. You put any value between 2 to 3, this will give you negative value. This entire thing become negative, and which is not defined.
Oh, yes. It's not according to the
definition of log.
Yeah, I got it. Sir.
Got it now? Okay.
Yes.
Perfect.
Sir.
Okay, now for this, now this is only the graph for this part. Okay. So now I'll just erase the other part. Now you see this thing, what you get, this is your f of x graph. I mean, of course, this entire thing. This is your f of x
Too
graph.
weird.
Too weird, right? But you will appreciate this, once you will be able to do the graph for this kind of things, you will be appreciate yourself, like, okay, you got to know this. Okay.
Can you take one more example? Bigger.
One more example. Polynomial function, na?
This is not a polynomial.
Positive, you can take.
Because there are a lot of breaking points are there.
Correct. This is logarithmic. This is basically composition of function. It's composition of logarithmic as well as polynomial. So this is not a polynomial anymore. It lost its identity. This is basically logarithmic functions. So you see now, could you tell me what is the domain of this function now? Yes, domain of this.
Sir, open interval
Open bracket 1 to 2.
Then open
minus 1,
interval
no,
3 to 4.
1 to 2 union, 3 to
3 to 4,
union,
5
to infinity.
Clear?
Yes, sir.
So you see, you guys know so many things now. What about range of f of x?
All real numbers.
Why? Because see, this is going towards negative. See, if you look at this part, you will see like, okay, no, this is not going to infinity. This is restricted. But look at this one. This is going towards infinity, right? So negative infinity to positive infinity. So it is R. Okay. Clear? Are you with me?
Yes, sir. Yes, sir.
Okay. Now I'll take up another example.
With positive
With what?
exponents.
Sorry.
Positive exponential.
Positive exponential means?
This was the odd, sorry, positive. And
Okay,
even.
you want the even degree polynomial. Okay, we can take that. So now let's see this, or okay, now I can just simply take these two values, and I simply want to bring to your notice that your domain is not always R. That is what I want to bring here, one thing. So now let's just understand this. Log of this part minus x minus 1 times x minus 2. Okay, so how will the graph look like for this? So whenever you want to plot this, take this entire thing, whatever is given inside, right? So I'll just take this, then I'll take an even degree one. I'll take another complicated one, and then we can discuss that. Okay, so now let's say this is 0, this is 1, this is 2.
Sir, you were telling minus log is not defined.
We'll come to this. Wait, no. So this is x plus 1, x minus 1. So this is going to be minus 1. So could you tell me the graph for only this part?
So it is negative, no?
That is negative.
Downward parabola.
Downward parabola.
Downwards.
And it is going somewhere
minus
No,
1
minus
to 2.
190.
2, right? So this is something like this.
Yes, sir.
Right? So this is the graph of minus x plus 1, x minus 2. Right? And where is its vertex?
1.5.
1.5. Is it? Or 0.5?
0.5.
0.5.
Somewhere here. Right? I'm not interested what is this value. Okay, so we can just keep that for time being. Okay, so now let's, so this is basically, okay, so I drew it like a, asymptote there, so just ignore that. So this is what it's going to look like, the parabola. Okay, it's going to increase and keep on increasing. So this is what the graph for this. Okay, now could you tell me what is log of this function? I'll take the red color. Again, now let's look at this. What is happening at 2? At x equals to 2, what is happening?
It won't exist.
Not defined.
Not defined. So I can simply draw a
Asymptote.
straight line. So that asymptote, right? So that is something like this. Okay. What about at 1? Not defined.
Yes, sir.
Minus 1.
Okay. Now what? Where all my log is defined? Is my log defined on this region?
No.
No.
Because
Negative.
because these are negative, right? So now then what? It is only defined in this part between
Yes, sir.
minus 1 to 2. So how will this bending happen? Something like this?
Yes.
Correct?
Not touching minus 1 and 1.
Not touching minus 1 and 2.
2, yes, sir.
Correct? So this is the graph for this log function. This is the graph for this f of x. Clear? All good?
Yes,
What
sir.
is the
Yes,
range
sir.
for this? What is range of this function f of x?
Minus infinity to 0.5.
0.5? Did you calculate that value? Because at 0.5, what do you get here? So if I have to put this value, so it's going to be 0.5. So it's going to be 1.5. And from here, I'll have minus 1.5. So if I take product of this thing, this will give me 225, right? So 2.25. So it's going to be minus 2.25. So minus of minus plus. So what is log of 2.25? Could someone tell me?
Yes, sir. Wait.
Okay, so let's say this was something log of
0.35.
sorry,
0.35. It is 0.35 to 1. Something.
35. Okay, so this is something, this part if I have to take, so this point will be 0.5 to
0.35.
right? So this is that point. So what is the range? Minus infinity to
0.35.
0.35 is included, right?
Yes, sir.
Yes.
This is my range. So see, your range will not always be from minus infinity to infinity. And for the person who was asking me, sir, this was negative, but now you understood, this f of x will be positive for only this region, right? So pay attention for this. What about domain of f of x? Could you tell me what is domain of f of x?
Minus
Negative
minus 1 to 2.
Infinity to
1.
infinity, excluding minus 1 to 2.
Minus 1 not in
Open
No.
bracket minus 1 to 2.
It is just minus 1 to 2, not infinity.
Open bracket.
Yes.
Yeah, it is this. Domain of f of x is this. That's all.
The function is defined under that quadratic equation.
Yes.
So,
Clear?
okay, sir. Yes.
Okay. So now we understood this part as well. Now let's go to some complex problem on this. Okay. So now we know how to find domain, range, and things like this, right? And okay, so it's just we are playing around with the graph. So now I'm very much confident that if an equation is given to you, you can easily plot the graph, right? All of you can
Yes,
do,
sir.
right?
Yes,
Okay.
sir.
So great. So I say that you know that much. Now let's understand, as somebody was asking, like, what about odd degree polynomials? So when you have it like x minus 1, x minus 2, x minus 3, x minus 4. Simple problem, right? And it's an odd degree. So how will the graph look like? Okay, maybe I can give plus, plus. So this, so that we can have that diversity here. So -1, -2. So this is going to be 3. This is going to be 4. And you see this graph. So this is even degree. And leading coefficient is, let's give it negative, right? So what is leading coefficient here?
Negative.
Negative -1.
Negative. So this is not going to, so it's, the graph should have been like this if it was positive, but since it is not positive and the leading coefficient is negative, it will be something like this, right? So at boundaries, I can say the graph is going to look like this, isn't it?
Yes, sir.
Yes.
Now in between, I can say that at this curvature will be something like this. Maybe I can give some more stretching here. Okay, now this is the graph for this. Now let's look at the log of this part. Okay, so I want you to help me now. What I will do is I'll simply take the roots part here. Okay, and I can simply draw the graph. All right. So now you tell me, at this part it will be infinity, right? Not defined.
Yes, sir.
At these roots value, correct?
Yes, sir. Correct.
Now it is positive here, so I can say this bending must happen something like this.
Yes, sir.
Yes, sir.
Correct. And over here also, this is another positive region, so this bending might happen like this.
Yes, sir.
Right. That's all. This is only the graph for this f of x. This is the graph for f of x. I mean, not just this, even this. Okay.
With the range.
So the range part for this becomes a bit trickier. It's just because, see, first of all, again, it's not very tricky, but it is tricky, and you will not be asked to find range for this kind of question, because we do understand here. Because see, this function was something like this, right? So you first have to know what is the maximum value for this, because once you know the maximum value for this, then only you can put that value on this and get the value, right?
Yes.
Since you cannot tell what is the maximum value for this function, as if now you know only for quadratic equation to find the maximum value and the minimum value, correct?
Yes, sir.
Do you know for any other functions? No, right? So we
No,
will not
sir.
give you that. We
Yes,
will
sir.
never ask you that. Yes.
So we can derivate it to get maximum value.
So derivation, you mean to say you need to, so that you will get into calculus part, isn't it?
Okay. Okay.
So we will not get into that part. But your f of x graph is something like this. Clear? All of you are with me, right? So you can tell domain and all now. Domain, range, of course, it's hard to tell.
Domain is -1 to -2 and 3 to 4.
But in your option, your range will be
-2 to -1.
Your range will be given like -infinity to positive infinity. Is this option right?
No.
No, sir. No,
So
sir.
this you will expect in your options, but certainly you will not get a right option. Of course. Okay. So yes, pay attention for this now. So I think now you're very good at graphing of logarithmic functions. Now we don't need any more explanation on this. Okay. All we can do maximum is maybe like this we can give, like log x plus 1 and x minus 1, not -1. Maybe all we can do is, I'm telling you from examiner point of view. Let's say if I am an examiner, I'll give it a function like this. Okay. Now you tell me the graph for this. Now becomes tricky, right?
Yes, sir.
We have to expand, sir.
The x-axis have to be +1.
Sorry.
सर यहाँ पर y इक्वल टू 1 पर ये ग्राफ स्टार्ट होगा, इस बेस शिफ्ट हो जाएगा +1 पर.
Correct. So यहाँ पे so what do you get over here is, so this will become -1, this will become +2. Keep it like that. When you give it as -1, what will this log x look like? Log x. When you give it
downward.
it will become log 1. What is log 1? 0.
0.
right? So this is going to be 0 at this part. What about, and see this, if you look at overall this graph, I mean, you can just simply think of this. If this part was your log function, so you can, how will the graph look like for this? This is going to be an up parabola, something like this. Only this part. Think of this part only. It's going to be something like this, right? Now what about?
I mean,
Sir, downward क्यों होगा, upward क्यों नहीं होगा?
Sorry, upward होगा, right? Something like this. If I'm just taking this part, isn't
Yes,
it?
sir.
Actually, its roots, it won't be 1, 2. It will be either यहाँ पे or it will be like here.
Sir, it will be shifted 1 unit.
No, that is hard to tell, but it will certainly not be 1 or minus 1 or 2. It will be somewhere like this, okay? Or it might be here. I'm not worrying about that, okay? We can just keep that aside. But you look at this part, but certainly it will not be minus 1 and 2, isn't it? Because you have this plus 1 factor there, right? But it will be very near to this one, either this side, or it will be in between this, okay? So now let's understand this. How will the graph look like for this log function? So when you give it 1, right? So your, when you give it as minus 1, what is your log, what is your f of x? It will be 0. And so this graph is something going to be like this. Okay. For this graph, this is something, it's going to be like this. And what important thing you have to keep it in your mind here is, when you give x equals to minus 1, you see this is going to be 0, right? It's not being asymptote at that place, isn't it? Asymptote is happening somewhere and we don't know what is that value. You will get to know the exact value once you factorize it, but I do not encourage you to factorize that. Okay. So now what do you see from here? When you give it x equals to minus 1, it is 0. So that means this will be 0, but this is happening somewhere like this. And it is going to be at 2, this will become 0. So that's, again, it will become log 1. So log 1 is 0. So you see, this is that place wherein this is happening, and rest all it's go like this. Okay, I'll mute everyone. Okay, so I hope you understood this. So whenever you get a questions like this, okay, just make the graph for that. Okay, just make the graph for this factors. Just make the graph as you know. Okay, and yes, sorry.
So that log function, it will pass through the 2 and minus 1.
So that will pass through this. Clear?
Okay.
Yes.
Okay. So
No,
whenever
sir,
you
can
get
you
a
please explain once again? I did not get it.
okay, so I'll just summarize it how it's happening. Whenever you
Yes,
get a
please.
question like this, let's say you have another factors here. Let's say plus 3, some x minus 4, blah blah, and let's say 1. So what you do for this kind of question is, you just
Sir, what is the domain here?
domain for this function. So domain
Yes.
for this function is yes. So the domain for this function is, you can say minus infinity
Minus infinity to minus 1 close bracket this time.
to
No, sir,
not
because
2 to
the
infinity.
root will be there, na?
So
We
here-
have to know the asymptote.
So see, one is included, that you can say, but you can say certainly that there are some values which will be included, okay,
yes, sir.
and which is really hard to find. And if it is hard to find, we will not give you like that, okay, but we will definitely give you a wrong option, something like that, okay. So we might give you the domain for this function is minus 1 to 2. Is this right?
No.
No, right?
No, sir.
No, sir, this is wrong.
Sir, because these two parts never intersect. Na?
See, because you don't know what is that small value here, right? If you have to find out, all you have to do is just expand this, find the real roots for this function, right? And then you will be able to find out its asymptote, isn't it? So that is something we will not encourage because you have a limited time in your exam, right?
Yes.
But yes, we will definitely give you a wrong option there. Okay. So, but again, like let's say if you have a complex problem, something like this, and then something like 8 plus 1 I have given. Okay. How do you get the exact values of your x-intercept for this part? You won't be able to get, right? But all assumptions you can make is you can just give the plot for this, right? Plot for only this part. And since this plus 1 is given, like I did it here, the quadratic equation was opening something like this, right? But it was not touching this point. That is what you have to understand.
Sir, how can I plot for this?
So this basically, yeah. So this quadratic equation, I can say like this, it was happening. Why? It was certainly lesser than -1 and lesser than 2, only if this was the case. This quadratic equation, and if I had given, okay, so this graph is for x plus 1, x minus 2 plus 1. Okay. Why am I able to say this?
Just shift it up 1 unit.
So it is just, it's just like this, but it is not -1 and 2. So do pay attention to that. Okay. But certainly this opening will be nearby. Okay. I hope this is okay for at least most of you. If isn't, just watch this video. Maybe you might get it. Okay. Okay. So having known this part now, so what we can do is I can give you a quick question on composition of function and test your knowledge. Okay. And the question is something like this. Now I'll give you a question. Log 10 to the power of 2x plus 5. Okay. I will do the two graphs for this. You will have to tell me what is the right answer. Can you tell me the graph for this function is? Can I say the graph for this function is like this?
Yes, it will become.
Yes, sir.
It will become 2x plus 5.
Can I say this?
Yes, sir.
Yes, sir.
Certainly this part, it can, this is 10 to the power of something, right? So this can take all the values of x, right? It can take all r values. And no matter what r value you take, this is always, as a whole, this is going to be a positive, right? This entire part. If this is positive, this is not violating my log definition, correct? All of you are with me? Yeah. So I can simply say that this is equals to 2x plus 5.
Yes, sir.
And the graph for 2x plus 5 will be
Linear.
something like this.
Yes, sir.
Okay. Now comes the another part. Now I have another thing, 10 to the power of log 10 2x plus 5. Okay, so now let's go with this. Now how will the graph look like for this one? Is it this one again?
Yes, sir.
2x plus 5?
Yes, sir.
All of you?
Yes, sir.
There you go wrong. This is not right.
10 to the power will come there. 10 will go there, 2x plus 5.
So when you expand this, you are saying this is 2x plus 5. Is it?
Yes.
No,
Yes, sir.
it will be exponential. 10
Yeah,
raised to
yes. Yeah, 2x to the plus 5 raised to 10.
No, but tell me what will be the domain for this function? That's what you should be more interested here. The graph for this function will be something like this. This is only the graph. 2x plus 5 only, but this is the graph. This is not the case. Why? I'm telling you why. Look at this part. 2x plus 5. 2x plus 5 has
Greater
to
than
be
0.
That
Greater
means,
than -5/2.
-5/2.
So it should be, x should be greater than -5/2. That is nothing but it should be greater than 2.5.
Yes.
So -2.5 will be somewhere here. So this part is not coming then.
Yes,
After
sir.
this, the graph is not defined for me.
Yes.
So my graph is only this. And hereafter, it says, no, you can take all the values greater than this. So you see, I restricted, this function is restricting the domain, right? I have to make sure the definition is not violated. In the previous example, like what I gave you, the definition was not violating and I got a clear cut 2x plus 5. But even for this, when I'm expanding, I get 2x plus 5. But I have to make sure that this is not violating the domain condition, right? So the domain for this is going to be x greater than minus 5 by 2, right? So you take no values of what, you will get a graph like this only, but you will not have this thing coming up here.
Got it.
Clear? Got it?
Okay, sir. Yes, sir.
Okay, so now we got to know this as well. So now we have 8 more minutes and we can discuss some more things. Like I will give you another question here and I want you to answer that question. Okay. Maybe like I think whatever I have to tell you, I have told already. Okay. And we have discussed it in a brief. Okay. But just to ask you, okay, we can ask simply like, how will the graph look like for log x plus 5? I mean, just log x plus 5. Could somebody tell me?
Move up.
Yes, it will be shifted by 5 upward.
So when x is 0, when x is 1, you will have it this as 5. Right?
Yes.
Here.
Yes, sir.
So this is something happening like this. Okay.
Yes.
Okay.
Yes.
So I guess like we have done with all kind of problems. Like you can ask me if you have any other doubt on this, or like a general doubt, or like if you want to simply ask me something, we can just talk.
Sir, a clarification regarding polynomial. Sir, for any specific root, if we have suppose we have a polynomial of degree 6 or 7 or higher, and for any roots which is in between like 4, can we predict how the graph at that root behave or look like?
Sorry, x to the power of 7. How will the graph look like for this?
In this polynomial of degree 7, if we have if we have x to the power 1 more 0 at x minus 2 is equal to x minus 2 to the power 4.
X to the power of 7 plus something like that?
No. Sir, in this polynomial of degree 7, we have a root of, we have a factor of x minus 2 to whole power 2. Is something
X
like
minus
that.
2 the whole power 2.
Yeah.
Okay.
Just while not drawing the full graph, can we predict the graph of this 0?
Okay. So is it like x to the power of 7 is your polynomial?
Yeah.
And you are telling this is your factor for this polynomial?
Yeah.
No, but that cannot happen. No, x minus 2 can never be the factor of x to the power of 7.
It's something like that. We have some x minus 3, x minus 2.
Okay, so you have some expression, something like this, x to the power of 6 plus blah, 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 something. And then you say this is a factor of this p of x, is it?
Yeah.
And then you have to draw the graph for that.
Yeah.
Let's say this is g of x is equals to x minus 2 the whole square.
Yeah.
Right? So if you want to do the graph for this kind of polynomial, you must know the other roots as well. Or at least you have to make sure that there are no other roots. Okay.
Okay, sir.
Let's say this is given and this is given. All what you can do maximum, you can do this p of x divided by q of x and then get your quotient here, right? But
yes, sir.
You divide and you get a quotient of x to the power of 5, which is a bigger polynomial, right? You still don't know how to factorize this. But for simplicity, you say you got a quadratic equation, but you see that quadratic equation has got no factors. So when you see it has got no factors, then you can simply say that the graph is bouncing. You can just draw the graph for this and get your work done. Okay.
So it will bounce upward, either downwards. Can we say where it will bounce? It will open upward or downwards?
So now when you have to make the graph for this, now let's say, so when you do this, so you got x minus 2 the whole square and then you got some another factors, right?
Yeah.
Okay, so for these kind of functions, it's really hard to say that, okay, but again, you will have some cubic function coming up, right? When it is x to the power of 7, then definitely you will have another roots here.
Yeah.
Right?
Yeah,
because
right.
Cubic function will definitely have another this thing root coming up there. a cubic function, right, definitely will have one root, isn't it? So now when this thing is divided, when you say this is 2, this is, if it is x to the power of 5, certainly it will have another root.
Yeah.
Right. So you can make an assumption there, okay, there will be another root, and then you will consider this as x to the power of 2. So you can say that 2 is something like this, and since it is x to the power of 7 opening upward, so you say this is going to bounce like this or whatsoever, but you will definitely get a root from here, one more root, and that will depend on that its root. Let's say that is something like so if I have
Sir,
to
sir, if we are given another factor as imaginary roots, x square plus 1, so in that case, can you find the turning points?
X square plus 1?
Yes, sir. X square plus 1 into x minus 2 the whole square.
You can still do there, but we'll tell you how. But for this, I'll come to this. But for this one, so for this kind of problem, whatever you get, right? So when it is an even odd degree polynomial, so odd degree polynomial will definitely have one root for sure. And here you are telling you are very certain that two of its roots are same, that is 2. So then if you reduce it, then you will have x to the power of 5. Again, this is odd, it will have another root. Then you will have to find out the other root and then plot the graph. Okay.
Yes, sir.
Yeah. Okay, so for these kind of things, like when you have it x square plus 1, so of course it has got a turning point, and that is something at here, right? So this is x equals to 0, so that is happening at this point, that is 0 comma 1. But this is very much certain that, okay, you know the graph of a quadratic equation, right? And since I know the graph of a quadratic equation, I can say that, right? But how will I do when it is some other degrees, right? How do we do that? That is what your doubt.
Yes, sir.
Okay, so for that kind of things, if you want to find out the turning points wherein no real roots are given, for that I don't think so with the existing knowledge you will be able to do that, the turning points. Okay, but for certainly, like when you have a quadratic function, for that you will be able to tell that we are sure of. But when you want to find out the turning points for non-real roots and a higher degree polynomial, you need another tool for like calculus or something to understand it. Okay. Okay.
And sir,
So yeah.
Sir, what will be the weightage of week 5 and 6 in quiz 2?
Sorry, what will be?
I mean, weightage of questions that will come in quiz 2 from week 5 and 6.
From?
I mean, from week 5 and week 6.
From week 5 and
will
week
we
6?
Get more questions from week 5 and 6?
You will get more questions from logarithm.
Okay.
Yeah. So yes, so I think like this is all from my end for today's session. Like you can and I think like whatever I have to deliver or give you knowledge on graphings and finding domains, it will suffice the need. You can solve your activity questions and practice assignments and graded assignments. I know logarithm itself is very vast, and frankly, even if you give me any question and if it comes randomly, even I'll have to struggle at that point of time, like how to do and what not. Okay, so we do understand that, and I also understand that you have very less time, and just after your graded assignments you will have a quiz 2 lined up. So we are making sure that at least what we are giving you and what knowledge we are giving you in the weeks, like let's say a logarithm, like whatever we are teaching you, and we refrain ourselves not asking you more complicated questions or things like that, right? So it's just that what you know in your syllabus, in your week, whatever it is given, be thorough with those concepts, okay? And do solve whatever the mocks we provide, right? If you are thorough with those kind of questions, I think that will suffice the need for this week. See, as you know that these weeks, I mean, each and every concepts, it takes time if you want to do a depth study. It's not going to happen in a what time is given to you. Let's say if you want to learn a calculus, 1 week is not enough or 2 weeks is not enough to learn the whole of calculus, isn't it? So we have to refrain ourselves from what can be asked what cannot be asked should not be asked, right? So what is been given to you, you just focus only on that. The whole intention of this learning, what is happening here, should be like that. Okay, because we can ask you any questions, but yes, whatever the new thing is being introduced, we definitely make sure that you guys practice those questions, right? Let's say if we come up with a new question or something, of course you will be asked a new question, but the concept will be something known to you. Even if you see the qualifiers, the questions what we asked, right? If you can see, if you can relate with your mocks, and in fact most of the questions were discussed in the live sessions. If you see the revision live session, I mean the one which we took it last time, if you
Yes,
could have
yes.
gone through that itself, you would be passed, right? I mean almost all questions were discussed. Of course the session was very lengthy, I do understand, and we actually get 2 hours to actually explain you the concept, but we also have restrictions. So since we cannot they cannot give us another session on any other day, so what we do is we try to extend our session, because we have to make sure like what we are teaching you understand, isn't it? I mean I cannot simply rush through and just be a monotonous study, so that will not help. I mean, and even I won't be able to, in fact I really don't like, like when I am telling something and I'm not getting response, like let's say if I am teaching something and you are not able to understand it, then there's no point for me teaching there then, right?
Yes.
So then it doesn't make sense. So that's how the session goes lengthy, so pardon for that. And yeah, so this is all, but for today's logarithmic session I think we have discussed a lot of graphings, and questions on domains can be definitely be answered. All you have to do is just stick on to the definition of log. Okay. Yes. Yeah.
Sir, when will we get our quiz one score?
Very
It is
soon.
already given on the email.
The quiz one.
Yeah, that
Quiz
is
one.
quiz one, right?
No, I think
Qualifier is quiz one.
for
Yes,
you guys,
that is-
but they are already a term student, so they haven't been given yet. The marks haven't given. So
Oh.
maybe we'll sign up that soon and we'll let you know that.
So
see,
when are we starting calculus, sir? Which week
calculus
is
will
that?
be your week 7.
And sir, when is the quiz 2, sir?
Quiz 2, is it?
Yes, sir.
Quiz 2, I think you'll have this month end or like the next month first week.
I think it's 31st of
It will be on
October.
Yeah,
31st.
it's
Yeah,
on
31st of October. Yeah, so this month end. So basically 31st of October. So you have very less time. So start practicing then. And see, I think for your end term exam, the criteria is like you have to. They'll be taking best of your quizzes, right? Like either quiz 1, quiz 2, quiz. You'll have 3 quizzes. So best of
And
2
best
out
of
of 3
2
quizzes
count.
will be taken. So if you are to ask me, you have to really focus on your this week. I mean, of course, if you are done with your qualifier and if you have scored okay marks, it's good. Calculus is something you will really have to put extra effort if you don't know, and if you start from the beginning, it will take time for you to learn. Especially for those people like who is not even aware of what it is, and like who have lost their touch with the studies for let's say like 5-10 years or something, right?
The calculus means all kinds of like differential calculus, integral.
Yes. You will have limits, derivatives, integrations.
Calc 1 basically.
So differential equations will have.
No differential equations, but these things.
So
you will
last
have
time
to-
we had graphs like graphs and all. They get near week 9 to week 12. We had a lot of graphs. So that will be repeated this term or like.
week 9, week 10 in the sense graph theory.
Yes, sir. Graph theory.
Graph theory is there, but that is there in your week 10 and 11. So your 7, 8, 9 is your calculus. 11 and 12 is your 7, 8, 9 is your calculus. 10 and 11 will be your this thing, graph theory.
So
No,
this
okay,
is
sir.
graph theory. This is not graphing. What we
This
are
is simple graphing of your functions. Graph theory is different. Graph theory is more like your computer science oriented. So the maths part, what is needed for in your this thing, at least for your for maybe it is more like CT, and which this
Okay,
will
sir.
be also repeated in your other courses like as you go higher with Python. But yes, we will do the maths part here.
It is very similar to CDs actually. The
Yeah.
graph theory.
Yeah. So, but we will focus here only on the maths aspect of it, and certainly
Sir,
you can
we
learn
will
it
be
at
having,
all.
you are telling calculus, we have to practice more. And then in there, in between, we will be having quiz 2, and also we have to prepare for quiz 2 also.
Correct.
My gap is 30 years. I am taking up after 30-year gap.
Oh my God. So in that case, what you got to do is you can simply brush up with your concepts. You can just take out your 11th and 12th standard book. Just simply brush through what it was.
I feel that all are changed now. Syllabus also fully
Okay, yeah.
changed.
So maybe like you can, like you can just take out the NCERT textbook. You can just go through this.
Sir,
I mean, just
seeing
the
what you are sending, I feel that also taking so much time. Where I have time to go with the NCERT book and all. What you are providing,
I do
I
understand.
feel that at least finish this much.
I do understand that. So you know, like it's a common practice. So for a new qualifier student, if someone is really looking for, they want to get into this process, I would say start learning before enrolling to the program only, because you have very less time. At least for maths, you have a lot to do in maths.
Sir, so
hello,
there
sir.
are.
Okay, go ahead.
Sir, there are a lot of NPTEL videos regarding the same topics that we discussed. So anything extra will be discussed in those NPTEL videos, or like everything that is required for the content courses in this our syllabus itself?
In our syllabus, like you can stick on to what we are teaching here. I don't know what NPTEL what they have thought, but in our course, you just stick on to our course here. Because
that will suffice for our examination.
Yes, definitely it will. No more extra thing will be asking. It's just the contents what we have. But do practice whatever we give. Okay. And it should be like every question is learning for you. It shouldn't be like, okay, now I know. You shouldn't, saturate yourself. Okay, now I know so much. You give me any question, I'll be able to do. That attitude should never come here, because the moment you will have this, you will have another question coming up, which will break that confidence. So you should always keep till the end that you are learning. Okay. And that should be your your intention, or like your attitude toward this course. Okay.
Sir,
Yeah.
excuse me, sir. Sir, I have one administrative doubt. Sir, suppose since the diploma entry program has been launched this term only, suppose if I want to enroll in a diploma entry level and get myself off from this
okay,
professional level course from here, so what I need to do? And further, I am a little bit confused that whether should I go for diploma, direct diploma entry, because I am from an engineering background and I have like completed my BTech this year only. So what I'm not like overconfident, but the maths part, which which are in the foundational courses, it's somewhat similar. So I am not like, it is not very difficult for me.
Yeah.
So I'm a bit
Usman.
confused whether to go for direct diploma entry or whether to continue.
Usman, I will suggest you, like, see, if you go into the diploma level courses, let's say you will be introduced to machine learning, and the prerequisite for machine learning is your maths 2 and stats 2. So if you can just quickly go through the topics what is given in maths 2 and stats 2, and you see how confident you are with that. And I think before getting enrolled in the foundational courses, you have to qualify some exams, right? Some pre-exams will be there, isn't it? So once you qualify that, then only you will be able to enroll in that. But you see, one or the other time you will somehow have to do maths 2 and stats 2, because these are very much needed for your machine learning.
No, sir. In the diploma entry, direct diploma entry level, there are maths 2 and stats 2 are embedded in the course. Like for the direct and diploma, there are a total of 8 courses. While if we go through the foundation, then we have to do 6 courses. So they are taking maths 2 and stats 2 in the direct diploma entry level for the students who are trying to join through direct entry.
Okay, Usman. Then in that case, you can take that, and certainly this thing you can do it.
But I think the diploma program cannot be scaled up to degree. It is not a
yes. Correct. You will just get a diploma certificate.
Yeah, so that's where they really put up a rider there. Had they really allowed a diploma can be scaled up to degree, then people would have gone in that route. Sir, I have a basic question here. Why do we get into so much deep into math or data science?
Sorry,
I mean, I just did little bit of certification programs with Neptal,
Okay.
and particularly the reinforced learning and the machine learning. And I'm not able to connect the level of math detail what we are doing in now to machine learning or the deep learning or the reinforced learning. There is a disconnect, I feel that.
Actually,
I mean, I don't know whether my observation is right or wrong, but
no,
still
I'll tell you. Yeah, I'll tell you what. See, in machine learning, if you see first 4 weeks content, it will be from Maths 2. And in fact, if you know Maths 2, I think the first 4 weeks of your machine learning will be very much familiar with that. In fact, you will find it easier in machine learning. So you see that is happening. So there
that
is
more on the, that's more on the computer graph theory, not on the algebra. Or,
no, there is.
Okay.
Yeah. So you cannot really ignore maths and stats too. Maths 2 and stats 2. Because see, what you do in machine learning is all maths again. If you are building a model, let's say you have been given a data, it's again maths. You need a maths knowledge. You can't do it without maths. And later on, it's just a computational tool that the maths thing itself, you will be doing it on the computer.
Where do we apply the math knowledge? Is it for the computer vision or for establishing the relations? Where is the math knowledge is applied? Let's assume that the sort of
okay, I'll tell you one example, a real life example where you can actually think of. So let's say like you have been given a project on machine learning. Okay. And let's say it's some data given to you, like, and that is data in itself doesn't make any sense, right? So let's say you have been given a 1 lakh data and you have a parameters. Let's say you have to predict something. You have to make prediction out of some data. Okay. You have been given various parameters, which can be many other things. Let's say our IPL here. So if you want to predict the score of, let's say, CSK, and then it depends on various parameters like what they have played in the last match, right? Then you will consider various other parameters like, okay, which player is playing. Then you will also consider the climate, the pitch. So these are all the parameters, right?
It's basically data manipulation, is it?
Data manipulation, but how will you make the model without maths? Now, so you will have to first plot, you have to make the model, right? So that modeling is nothing but your maths, isn't it? Like, see, somebody asked me like, okay, logarithmic, where is it used? So I was just telling him that, okay, you never know where can be used. It can be used in your stock markets. So he himself pointed out, okay, it is definitely used in stock market because some part of it is a log.
Yeah, right? I can understand definitely stock market or algorithmic trading has a lot of lenience on math. Of course, that is area where math is definitely needed. Anyway, it's
no worries.
Basically, my level of understanding is not reached there.
See, you will, but trust me, you will appreciate all these learnings once you go to that level, and you will have that thing definitely coming into picture. So no worries.
Right. Thank you.
Once you should check the chat box.
Oh, is it? Sir, how to register for foundational courses provided I have qualified the qualifier exam? So if you qualified the qualifier, this is what your question is?
Yes, sir.
Okay,
good morning, sir. Yesterday I received a mail that I have qualified the qualify exam.
Okay.
Now on my IIT site, it's showing that course registration, but when I click on it, it is saying that I cannot access it or something like that. Just a second, sir. I'm telling it. It is telling that you are not allowed to access the course registration. So
okay,
then
maybe they haven't enabled yet. I'll speak to them when it is happening. Okay.
Okay.
But soon it will happen. You will be enabled.
I think it will start on 18.
Okay.
So I have a doubt regarding the logarithms that we discussed today. So we were talking about the log of x to some power, right? Like x square or x cube or something. So can we use
can we what?
Can we use the properties that we discussed today to like find something about the graph?
Okay, the properties, right? Yeah, we didn't use property much here, right? But these properties will be useful while solving the questions. Like, let's say we have been given an equation to you, okay, like something log of something plus log of something is equal to something. An equation is given to you, right?
Yeah.
So now you will be expected to solve that equation first. Now see, whatever graphing I have done, it was like a very straightforward log of something, right?
Yeah.
And we were able to draw the graph.
Yes.
Now see, when you have log of something plus log of something is equal to something, so what you are supposed to do there is use the properties, come to simplify it, you will definitely get a good expression, and then you can make sense out of that. Like once you get, like, let's say log of something plus log of something, so you can simply simplify that by using the properties of logarithm, right? And you will definitely get at the end one fine expression of log. Then you can make use of that part. Now there comes the graphing at the end, right? So that's how you can make useful, or you can connect both.
But I had a different doubt at like while we were solving the graph, right? So at first I thought, like, log of x square would be like two, like if you use the property, it would be 2 log x, right? Log of
Yes. So
Yeah.
see, there you make an assumption. When you say log of x square, then you can simply say 2 log x, right?
Yeah.
But what is the assumption you do there? So you say that
X is positive.
so that assumption you take and then you go ahead. Okay. So that's how you it's a good question actually. So you do pay attention, like when you are shifting something, you are not violating the domain of this, right? So do pay
So
attention. Yeah.
So even if, like, whatever it is, if it is 4x and x plus 1 the whole square or something, still we can use that as long as we are restricting to the domain.
Correct, definitely.
Okay.
Okay, so yeah, so we can stop our session here now. And
Hello, sir.
Yeah.
Actually, I needed an opinion on how many subjects shall I take, because I'm qualified for the 4 subjects. So actually wanted your opinion. Like, I can give you my background and what I want to achieve from this course.
Okay.
Like I'm familiar with the math and somewhat, like not all, graph theory I'm not familiar with, but basically like calc 1 stuff I'm familiar with, and whatever it was taught, like coordinate and all, so I'm familiar with those. And for the stats part, I'm familiar with stats 1. And for CT, I used to do Python programming, so I'm good at CT also. So
then you can take all 4 courses.
Okay.
Yeah, you can do
like what I want to achieve, like I want to understand every topic in depth actually.
In depth, that means you want to give more attention to every week, right? I mean, of
Yes,
course,
sir.
everybody
Like
does that.
everything, whatever is taught, right? Like for math, like you're now we're learning logarithm. So I want to understand logarithm in depth, like everything, like from different resources also. If I can find like a books.
In that case, no, Harkishan, what you can do is you can actually take 3 courses and then take another courses the next semester, and that is something you can do. In fact, even here right now, you see term 1 student, there are many students who have done like that. You can opt for that as well. Or if you're fine going through, if you have enough time and you think like you can do it and you're already familiar with the things, then it's your call. So that's the thing. But if you already are familiar with calculus and graph theory might be a new to you, but that's not much. And since the graph theory will be repeated again in CT and Python later on, so that is something you can learn again. So that is there. And also, like, you are also aware of stats and you are good at Python coding, so you must know logic, then CT should also be okay. So I think you can take 4 courses as well, but no compulsion. If you feel like, okay, you don't have to burden yourself at one go and land up with nothing, so it's better to take 3. It's completely your call, but see what you can do, right?
Yes, okay. Because after this, I think I want to pursue some research career. So I want to understand the topics in depth. So yeah, that's the part.
Yeah,
actually, I'm following a book for now. Like that was a college algebra by Kaufman. So yeah, I'm following that book.
Okay, that's a good book. You can do that.
Sir, I have a question regarding grade assignment week 5.
Okay.
It's question number 2.
What is the doubt in that?
Sir, the question is for y is equal to x power n, where n is a positive integer and x belongs to real. Which of the following statements are true? And the first option was, for all values of n, y is not a one-to-one function.
Okay.
So I think it should be true.
For all values of n, y
is not a one-to-one function.
Y is not a one-to-one function. For all values of n,
y is not a one-to-one function.
Okay, why do you say it is true?
So because for all values, y is not a one, like for for n is equal to 2, y is not a one-to-one function. N is equal to 4, y is not a one-to-one function.
Okay, for all values of n, y is not a one-to-one function. Okay, but this is partially correct, no?
Yeah.
Yeah, this is partially correct, isn't it? It says for all values of n, right?
Yeah.
What about for 3?
Sir, then it is a one-to-one function.
And for 2?
It is not.
So it says for all value of n, right? For 2, it is violating this. So it is not true.
So why do you say y is not a one for all values of n? Y is not a one-to-one function.
Okay, so then you take it an odd value, no? Then you take it an odd value. For odd, it is not one-to-one.
Sir, but it is given for all values of n. It is not a one-to-one. For some values, it is a one-to-one function.
This is actually a partial right statement, isn't it? So it is wrong. So what you can say is you take n equals to 3. At 3, it is one-to-one function. Right? See, when you have to disprove something, you just need a single statement or like a single condition to disprove it. But to prove that that is right, you will have to prove it at each and every point. But to disprove it, single point is enough to disprove it, right? So when you take n equals to 3, at 3, it is an on-to-one function, but this statement says it is not one-to-one function, right? So this is wrong then, like that.
Sir, confusing.
Yeah, so that's what I'm saying. No, for all, this is, I told you, right? So when you are taking, when it is even, so when you have to prove something, you have to prove at each and every point. But when you have to disprove it, you just need a single point to disprove it. So I'll give you a single point here. Take n equals to 3. Right?
Can we approach? I think can we approach this way? When the function, when n is an odd and even, then it is on-to and one-to-one, no?
So you can say it in that way. When it is odd.
Yeah. No. Just allow me to finish. Okay. When n is even, then it is not an injective function, and when is an odd, it's an injective function. Okay.
Correct.
One-to-one function is taken care in that one.
Correct.
But now go back to that statement, original statement. For all values of n, y is not an one-to-one function. That is the right one only, no? If you read these two statements together, then read the third statement as the first statement, then that sounds correct only. If there are, it is not one-to-one for all values of n. That's the fact of the matter, no?
1 minute. For all values of n, y is not a one-to-one function.
Yes, so it is not a one-to-one function. There are certain values.
Sir, I think the statement should be for not all values. It is plainly given as all values of n. So it should be like not all values of n. It should be one-to-one.
Okay, I'll do one thing. I'll just look into this. Okay.
Yes.
I'll look into this again, and let me think over it. I cannot just tell you anything right now. So let me think over this and discuss with my colleagues.
Yeah.
And then we can we can conclude something. Yeah.
While you are revisiting the question, better read the last two statements, then read the first statement of the option code.
Yeah, I get it. Yes.
Then the perspective is changing.
Okay.
So it sounds that the first statement could be possibly right.
Okay.
Yes, sir. That's my understanding actually.
Okay. No problem. We can just look into this again. No problem.
Sir.
Sir, even I do have a doubt in week 5 graded assignment.
Okay.
In the second question,
okay,
we are given f of x is x square and h of x is x minus 1. And then we have
fifth question.
No, sir. For me, it's the seventh one.
Okay, seventh question. Okay.
There we are given f of x is x square and h of x is x minus 1, and we are asked to choose which option is incorrect.
Okay.
In the second option, it's given q of x is equal to f of x plus h of x. So in that case, q of x will be x squared plus x minus 1.
Q of x is x square minus x plus 1.
For me, for me it's given q of x is f of x plus h of x in my graded assignment.
Okay, just let me look at this. Is my screen visible?
No, sir.
No.
Okay. Yes. I think after this we can end the session. Okay.
No doubt, sir. I was waiting.
Sir, I have also a small doubt.
Okay, we can take this. Just a minute. Question 7, no, for you, right?
Yes, sir.
So question 7, what were you telling? Could you go ahead?
For me, it's given q of x is equal to f of x plus h of x.
Okay, yes.
So in that case, q of x will be x squared plus x minus 1.
Yeah, x square plus x minus 1.
And then we are given q of x is a bijective function if q of x is defined from r to semi-closed minus 1.25 to infinity. So in that case, if I take if I put x as 0, I'm getting q of x to be minus 1.
Okay.
And then if I take x as minus 1, I'm again getting q of x to be minus 1.
Okay.
So because both 0 and minus 1 have the same image minus 1, we can say that q of x is not 1-to-1 at all. So it cannot be bijective, no, sir.
Yes, they said incorrect option, right?
But you have to choose the incorrect option.
Yes, sir. So I've chosen that option as incorrect, but I'm not given marks for that. It says only the two incorrect options are only option C and option D.
See, you have been given that plus, right?
Yes, sir. No. We have to choose which option is incorrect, no, sir. So I've chosen option B, C, D to be incorrect. But then I've not got marks for that. It says accepted answers are only option C and option D. It identifies only option C and option D as incorrect statements.
Okay, so now if I have to show you the Desmos plot for that, okay. Let's see this.
Are you sharing your screen?
I'm going to share now.
Okay.
Okay, actually I have been disabled now to share my screen.
Sir, I'll be logging off now. Thank you for the session, sir.
Sir, hello, sir, are you there?
It's 12 hours.
I'm sorry, I was on mute. I was speaking from that time. All right. So this question, the question which you told me that the one that q of x is equals to f of x plus h of x, right?
Yes, sir.
So this is incorrect statement, right? And you have to choose the incorrect statement only.
Yes,
isn't
sir.
it?
And I've chosen that statement also as incorrect, but I have not been given marks.
Okay. Could you share me the? Could you put it? You're a term 1 student or qualifier?
I wrote the qualifier recently, sir.
Okay, so what you can do is you can put it in a forum once. We'll look into that.
I've already put it in the forum, sir, yesterday night, but I didn't get any reply.
Okay, fine. So I'll look into that. No problem.
My question, sir.
Yes.
Sir, suppose there we discussed log x plus 1, and next is log x, and again separately plus 5. Suppose not 1, it's 5. And there are also log x plus 1 together in domain. Then what's the difference between their two, sir?
Could you come again? I cannot share my screen, so just tell me again. I'll just note it down.
Sir, log x plus 1 separately, log x and then separate plus 1, okay?
Okay.
Or log plus 5 we can say, or whatever constant we can take. And next is log x plus 1 together, x plus 1 in domain.
X plus 1, log of x plus 1.
Or 5, whatever. Okay, sir?
Yeah.
We discussed plus 5. So if we take plus 5, then log x plus 5 separately, it will be shifted, right?
So see, now when you take log x plus 5 and then you are telling log of x plus 5, right?
Yes, sir. Yes, sir.
So how will the graph look like? So just try it out. So when x is equals to 0, what happens? In the first one. When x is equal, when x is equals to 1, what happens?
It will become 2.
It will become 5, right?
Yeah,
6. No, not 6. It will be 5 because log 1 is 0. So 0 plus 1, 5. So at 1, wherever you were saying, it will bend towards 5, right? But now take at this one, log of x plus 5. Now, where do you think it will be infinity? Where it will be not defined? At minus 5?
Yes, sir.
Right?
X is equal to minus 5, y equal to minus 5.
At x equals to minus 5, log of x plus log of minus 5 plus 5 will become not defined, isn't it?
Oh, it will be shifted by vertically by 5 unit upward.
Yes. So its asymptote will be at x equals to 5. But in the on the other case, the asymptote is still same.
It will not be shifted.
It will not be shifted, correct.
Oh, okay, sir.
Okay, so fine. So this is all.
Sir, I am also left.
Okay, tell me,
Sir,
Mahi.
like in the qualifier first question, the option is gx equals to close bracket 4 to infinity. Sir, is this correct? Like strictly decreasing, my 4 should be open bracket now.
For qualifier, you are telling?
Yes, sir.
Okay, for qualifier, what you can do is.
Number 1.
Okay, so this is last question. After this, we can end it. Okay. So for qualifier, right?
So just need a clarification, like strictly decreasing के लिए close bracket होना चाहिए open, like open होना चाहिए.
Strictly के लिए open रहना चाहिए.
So sir, why like C option is correct?
G is strictly increasing in 4 to infinity. Acha. So I got it. Like first question of your qualifier, right?
Yes.
Okay. तो तुमने उसका graph बनाया था?
Yes.
Okay. So now once you made the graph, you would see that strictly increasing, strictly decreasing का concept कैसा रहता है? Like how do you get that?
Like
see, when you see included and not included depends on where is that bending happening or like where the definition is violating. Correct?
But at 4 we are getting 0.
So that is still okay. That is still okay. You have to understand here that see at 4 still it is going to give you 0 and that is still uniquely mapped. See, and even if you take it from, let's say, if I give it as 3 to infinity also, if I give it, right, it will still be an strictly decreasing function still there. I mean, whatever in your case, if it was increasing or decreasing, it'll still be the case. You don't have to, I think you have a doubt. Okay, I think I can share my screen, right?
You are telling if we have a turning point, then only we do not include. Like
Okay, I will tell you strictly increasing and strictly decreasing thing. Pay attention to that.
Yes, sir.
You can see my board, right?
Yes, sir.
Yes, sir.
So now you see when you have a graph something like this, okay? Okay, if this is -2, -3, -4, oh sorry, let's say this is 2, 3, 4, 5, okay? Now strictly increasing means what? See, from here, even from 5, or you take it any point from here also, it is still increasing only, no?
Yes, sir.
Right? Now look at this part. Maybe if I consider this, can I say from 4 to infinity, is this strictly increasing? No, it is going down, right? You will see at this value you are getting, it first decreases and then increases, correct? Now look at this part. Now understand this. Look at this part, okay? Now let's say this is 4. Let's say this is 4, okay? Like I can do some kind of bending, like the graph is something like this. So Mahi, what you have to understand here is that you have to look at the graph and understand this. So if it's strictly increasing, strictly decreasing, function is good, it's okay, you understand, but this is the domain what we are telling, right? So the domain part will make it clear. Like if I say from here 4 to infinity, if you see from here till here, it is strictly increasing only, right? There is no bending, nothing is happening here, isn't it? Or bending in the sense there is no two values which is decreasing in nature. It is increasing at every point. That is all you have to make sure.
Yes, sir. But sir, if there is at 4, there is a bending, then what happens? Then what will happen?
Okay, so let's say if here it was like this is 4. So my, you see in this case what is happening, and let's say this was 4.1. So from 4 to infinity, what is the thing happening?
It's still increasing.
No,
Like,
it decreases first and then it increases.
oh yes, 4 is sir, I'm not seeing clearly. Like,
okay.
Where is 4?
Now?
Oh yes, yes.
So if this is 4, now if you can see 4, and if this was 4.5, and if I say something like this, then can I say that it is strictly increasing?
No.
Right? So pay attention to this part. So see, if you want to understand this kind of problem, what you have to do is you have to really look into the graph, whether it is increasing or decreasing type. Now if I can clearly say this is strictly increasing from 4.1 to infinity, and even 4 is included here. It is. I can still say if this was let's say 4.08. Look at this graph from 4 not 4.08, yeah 4.08. From 4.08 to infinity, is my function still increasing? The answer is still yes, because look at this graph. Is it bending? I mean, is this kind of condition happening? Is it decreasing? I mean, is it decreasing at any point of time? No, right? As you go ahead with this values, this part is always increasing, isn't it?
That way it is increasing from the vertex itself.
That is definitely right. It is increasing from vertex, but she wanted to understand why when you are telling, I mean, she got confused with at
Yes.
4, it is giving me 0. How can 0 be strictly increasing? Is it?
Yes, now I got it.
Okay.
But sir, what is the difference between strictly increasing and increasing?
Strictly increasing and simply increasing. So now look at this graph. Okay. Is this strictly increasing?
No, because
Oh, right.
there is a constant.
But it is increasing function. But is it strictly increasing?
No.
Yeah. So this is something happening.
Thank you, sir.
Okay. Can you explain that? Sir, please have that screen.
Okay.
That same problem. I got that, but once in the screen it will be much better.
this one, log of x plus 5.
Yes.
Have log of x plus 5. Is it?
Yes, yes, yes.
Okay, so if I draw the graph for this one, this graph is going to look like this, right? Okay, not exactly. But if this was 1, this is 5. Right?
Oh, yes.
Look at this. This graph is going to be like this only. But at here, this is going to be minus 5.
Oh, it will be stretched to the negative.
Correct. So, right. So, sorry, this is minus 5. No? So, this will be somewhere at minus 5 that is happening, isn't it? So, this is something going to be.
It will cross at minus. No.
At x equals to minus 5.
Asymptote will be at minus 5.
Asymptote will be at minus 5. But when it will be 0, when you give it as when your x is equals to minus 4. So this is minus 4.
Oh, 1 unit away.
So
Yes.
0.
Okay, sir.
Clear?
Got it. Yes, I got it. Very clear.
Okay. All right, then. Thank you, everyone. So you can practice now and put it in the forum. Whatever doubt we have, we'll take it from there. Thank you.
Thank you, sir.
Sir, a request.
Thank you,
Okay,
sir.
please look into the 7th question of the.
Yeah, sure. We'll do that. Yes. Thank you for
Sir.
participating. Yeah.
Thank you, sir.
Thank you.
Sir.
Yeah.
Sir, regarding Tuesday session, sir, we have Tuesday session from 5 to 7.
Right.
And from 7 to 9, I have Python session.
Okay.
But the Tuesday session is always from week 1, it's more than 3 hours. Yeah, approximately 3 hours.
Okay, so what you can do in that case, no, you can see the videos thereafter, like YouTube videos.
Sir, I have seen that, but the last part is interactive, mostly interactive part, questions.
Okay, fine. Then what we can do is
schedule clear.
Maybe I'll tell Devjyoti to not take that much. I mean, he'll try to finish it.
No, in fact, we were requesting repeatedly not to really put programs on back-to-back basis, at least to leave 1 hour gap so that it makes, because the spillover discussions are very valuable.
Okay.
Support team, it's not reaching, they're not getting up the message, I think.
We requested it multiple times, but we don't get that permission. So actually they have some kind of logistics issues, the time management thing. So they does it like that, but it's okay.
It is defeating the purpose because the 2 hour long discussion is getting summarized in the last half an hour.
Oh.
And that is really the gist of the whole effort. And most of the time we are not able to participate.
Fine, we can put this again, but I don't know they'll take any.
Yeah.
But yeah. So yeah, fine. Regarding that, I'll speak to Devjyoti. Maybe he'll try to finish it earlier or something. Yeah. Thank you.
No, that is counterproductive. Thank you.
Yeah.